ठीक है, दोनों पार्ट्स में जरूरी है। ठीक है, नंदा से
advisors joining us today. I, Akanksha Agrawal, PhD scholar at MNIT Jaipur, on behalf of EICT Academy and Electronics and Communication Department MNIT, feel honored and excited to welcome you all to the inaugural session of Faculty Development Program on Advances in Optimization Techniques AOT 2022. This FTP is jointly organized by Electronics and ICT Academies at MNIT Jaipur, IIIT DM Jabalpur, and NIT Patna. This FDP is an intensive 2-week online training program. It is being organized for faculty of engineering and technological institutions. It is also open to people from industry and doctoral students of Indian organizations. The main theme of training program will be oriented around exploring state-of-the-art methods for advanced optimization techniques with MATLAB and Scilab. Let us start our program with lightning lamps in front of Lourdes Saraswati. I ask Professor, our Director Sir, Professor Vipin Chawla Sir, HOD Sir, Rajesh Sir, Ella Ma'am and Piryasamy Sir to please come up on the stage and light the lamps. I also welcome Professor M. Sharma Sir, Registrar MNIT to join us please.
Would have been in the early morning.
Foreign participants are there. Foreign participant कितने हैं?
Thank you everyone. Now I would request Professor Vineet Savla sir to welcome our guest, Professor N.P. Padhi sir, Director MNIT with a bouquet.
My pleasure.
No, done.
My pleasure.
I request Dr. S.J. Nanda sir, Coordinator FTP of AOT 2022 and co-CIE and ICT Academy to welcome Professor Love Bhargav sir, HODEC. would request Dr. Ila Sharma ma'am to welcome Professor Rajesh Kumar sir with a bouquet. I would like to request Professor Love Bhargav sir, HOD EC Department at MNIT Jaipur, to address the audience and tell us about our institute and department.
We can skip the slide.
Oh,
We can skip the slide.
Yes.
And our Honorable Director, Professor Padil sir, distinguished guests present in the hall and online, welcome to this particular course on advanced optimization techniques and hands-on, which is being organized by MNIT under the aegis of Electronics and ICT Academy. So I welcome you all to this and would quickly like to tell you about our institute, Malviya National Institute of Technology, Jaipur. This was established in 1963 with the name Malviya Regional Engineering College, Jaipur, and in 2007 it was declared as Institute of National Importance by the Government of India. It is situated in heart of the Pink City, Jaipur, and has a lush green campus spread over more than 317 acres. We are an institute with a very rich pedigree and have almost 60 years producing world-class engineers, managers, architects, scientists. The institute is ranked 46th in the NIRF ranking under the category of engineering research and training. And in the area, we are recognized in the band excellent in the Atal rankings of institutions on innovation and achievements. The institute has got 13 departments and 3 centers of excellence, and we have more than 5,000 students on the campus across UG, PG, and PhD. The institute has 281 faculty members, and these are some of the glimpses of our infrastructure, where we are showing you the canteen, the hostels, the dispensary, the institute guest house, and the other buildings which make up, but as we know, buildings are one part of it, but it is the students and the faculty which make up the core of the institute. So quickly, I'll introduce you to the Department of Electronics and Communication Engineering. We started in 1981 as part of Department of Electrical Engineering, and the department was separately established in 1984. Currently, at undergraduate level, we have an intake of 117, and we have 4 PG courses with intake of almost 25 each. The faculty strength is 26. We have almost 111 PhD students. And in the previous year, we had more than 104 journal publications and 40 conference publications. And in the first quarter of this year, sir, you would be happy to know we have had 50 publications in journals, 10 in conferences, and we hope to surpass the results of last year by almost double the number. Our PG students, PhD students, PG and PhD students in the faculty form the core of the research activities, and the UG students also contribute to it through the minor projects and some projects which they take up with the faculty. The institute has been the department has been very active in organizing various programs and conferences. Some of them I'll name out are the 5th International Conference on Optical and Wireless Technologies, the 4th IEEE Conference on Antenna and Propagation, 7th IEEE Symposium on Smart Electronic Systems, and the 3rd Springer International Conference of Paradigms of Communication, Computing, and Data Sciences. Along with this, we have been regularly organizing faculty development programs under the aegis of Electronics and ICT Academy. And this is a series of programs, as you are all aware, where the 7 academies are working together to provide trained manpower, or training the trainer is the core of that philosophy. The department has 15 labs spread across, covering almost all the specializations which are there, and we are in the process of establishing labs in niche areas like artificial intelligence, IoT, machine learning. So with this brief introduction about the institute and the department, I once again welcome you to this. And sir, I would like to thank you for having spared time to be present for this inaugural function. Thank you so much and welcome. Thank you.
thank you, sir. Now I would request Professor Vineet Savla sir to brief us about the EICT Academy. Professor Vineet Savla sir received his
respected Professor M.C. Padi Sahab, our Director of MNIT Jaipur and Chairman of Advisory Board of EICT Academy. Thank you very much, sir, for your gracious presence here. Professor Law Bhargav, HOD ECE, Dr. Nanda, Dr. Ila, Dr. Peraswamy, Dr. Rajesh Kumar as expert here, Professor M.M. Sharma, Registrar Sahab, and other CIs from other academies, Professor Ojha and Dr. Bharat Gupta, and my other colleagues from other academies who are coordinator of this program. I welcome you all to this inaugural session of the program on behalf of this coordination committee. I'm here to just present a brief of what we have done in the last 7 years, the joint efforts from 7 academies. The methodology for jointly organizing has enabled us to reach a combined target of 92,000 function faculty trainees. This is a big achievement in the last 7 years. This phase is going to be over by 30th September and then would be running in a self-finance mode. At MNIT Jaipur, we have achieved the target very closely through 145 programs organized in the last 6 years or 7 years. Approximately trained faculty members are 12,000 and total participant trained are 14,500, which is almost achieving the category A academies, whereas we have been granted in category B. The total outlay have been 7.8 crore there. So I take rest from this part and let it go. Thank you very much.
Thank you, sir. Now I request Professor Rajesh Kumar, sir, to address the audience with a brief history of faculty development program on advanced optimization techniques.
So yeah, good afternoon to everyone, and one of the happiest person today here in this workshop, because this we started long back in 2015 from Department of Electrical Engineering with 60 participants, and then repeated in 2016. We extended from electrical to mechanical and chemical engineering department. In 2017, then we extended to electronics department, and from there Dr. Nanda took the charge of all these things. 2018, then it's a combination of again 2-3 different departments: electrical, mechanical, and chemical engineering. And then 19 of it was conducted by Dr. Nanda, and I think this is the right time when ICT also comes into the picture, and you can see the participants, they are in places like, people are waiting for this workshop, and I'm thankful to Professor Savla and Dr. Nanda to take it at a big level. Now it is at an international level. So that's a brief about this course, how we started. So now it's a 7-year course, 7-year-old course, quite mature. Thank you very much.
Thank you, sir. I now request Dr. S.J. Nanda, sir, to brief us about this faculty development program.
So I welcome all the participants and the faculty members of AOT 2020. In this particular program, there are 25 keynote speakers from IIT, NITs, IIITs, and other reputed institutions. There are 33 theory sessions, 9 MATLAB, Scilab-based laboratory sessions are there, 2 quizzes are there, and this program is jointly organized by MNIT Jaipur, IIIT DM Jabalpur, and NIT Patna. For this year program, there are total 298 persons have been registered for this particular program as participants. At MNIT Jaipur, there are 192 participations, IIIT DM Jabalpur 96, and NIT Patna 10 participation. Total number of research scholars participated are 122, 15 from IITs, 48 from NITs, 7 from IIITs, and other university research scholars are 52. That signifies that a lot of researchers are taking attention for this particular program. There are total number of 138 faculty members are there, and 38 UG/PG students are there. So move on to the next. So these are the classification of the people's registered all over the India, from IIT Guwahati to Gandhinagar to Roorkee. From all our research scholars have been participated. From all the NITs, 48 research scholars have been participated. From IIIT 7 and other institute, 52 research scholars have been participated in this particular program. So it will be a 2-week very intensive program. So that much I welcome you all. Thank you.
Thank you, sir. Now I request CI IIIT DM Jabalpur, Professor CI of EICT Academy at IIIT DM Jabalpur, Professor Rajita Ghosh to address the Oja to address the audience.
BK Panigrahi, Professor BK Panigrahi.
I request Professor BK Panigrahi, sir, from Department of
Yeah. Good afternoon. Am I audible and visible? Perhaps.
Yes.
Okay.
Yeah,
Yeah. So thanks, Professor Nanda, inviting me, and Honorable Director Professor Padi, and Honorable heads of the department who are present there, and some of my friends as well as students who are online and offline in this particular program. So this is a great opportunity actually for me, because my expertise is basically I do work on this advanced optimization technique. So when I work on those techniques, so these techniques are very useful, and I'm happy, as Professor Nanda has told. So there are 298 participants who are taking part in this, and as per Professor Rajesh, this is the 7th year of this program, or already seventh program has been completed, and this is 8th, whatever. So this shows that the rigorous, the intensive approach of all these three academies at present, NIT, MNIT Jaipur, IIITM Jabalpur, as well as NIT Patna, to attract the great talented. But I'll be more happy if more and more UG and PG students will join in this program and later on. So these programs are completely interdisciplinary in nature. So as these are very interdisciplinary in nature, so I urge everybody to take the advantage of that. You may not be able to understand few of the application, but at least you will get the gist of it. Take it on your own, try to apply it to solve the problems. And always I used to tell, these are the tools and techniques which are very helpful. And the more and more program you will attend, then your tools becomes more and more sharper, so that we can get more and more knowledge to solve the real world problem. I must encourage, it should not be limited to engineering only. It should be limited to engineering, science, management, all the disciplines, including the mathematics and others. So that's I must appreciate the effort taken by, in particular, all the faculty, staff, as well as the director, all the supporting staff, as well as the students of MNIT Jaipur and other two institutes to make it a grand success. Thank you. Namaskar.
Thank you, sir. Now I would request Professor Prashant Jain, Department of Mechanical Engineering, IIIT DM Jabalpur, to address the audience.
Thank you, the entire organizing team, Dr. Nanda, and the respected director, sir, Professor Padi, Professor Saula, Professor Rajesh, and Professor Bhargav. It's always been a pleasure to work with you all, and especially with Dr. Nanda. And I remember the organization of this course. I must want to share with all the colleagues here. The participants, the future participants really wait for the course. They wait for the announcement. They look for the MNIT Jaipur website and many times to contact to us. That's the beauty of this program. This program itself has its own name with a tag of MNIT Jaipur. So I am thankful for being given the opportunity to be associated with this wonderful team who work with a lot of enthusiasm, lot of encouragement with all the students, faculty, and participants. And people are very really care for the participants, because I receive many times the call from participant. I have paid some amount wrongly to the academy, and by within 10 minutes I may have received the call from MNIT Jaipur Academy that, okay sir, this has been paid to your account or my account, how to handle it, and to reply to the participant. So this is how we take care of the participants, how we deliver the content, how we share the lecture notes, and how we give them the hands-on experience-oriented sessions in this course is the beauty of this course. So with this, I would want to again ensure all the participants, being the joint coordinator of this course, we will help you again in the same way and we will conduct the course in the same manner. And I'm thankful to Dr. Nanda and Professor Padi for giving me this opportunity to interact with you all, even in this inauguration as well. We will be interacting with participants in other sessions. Thank you, sir.
Thank you, sir. I request Professor J.P. Singh, sir, Department of Computer Science and Engineering, NIT Patna, to address the audience. Over to you, sir. Professor J.P. Singh, sir.
Sorry, I just forget to unmute myself. Good afternoon, everyone. Good afternoon, sir, Director, sir, of MNIT Jaipur, Professor Padi. Good afternoon, Head of Department of MNIT Jaipur, Professor Bhargav, and obviously Dr. Nanda, whom I am associated for last 3 years of this course. And what I have seen that this course is obviously one of the well planned, where the first week is mostly about the theoretical development, where we come around the optimization technique, how to develop the theories for optimization, and the later half is mostly about the application in different domains. So this is really one of the well organized course. I've been associated for 3-4 years right now. This time, I'm very sorry to the team that from my side, there is a very limited number of participants registered for this course. But next year, obviously, our NIT partner team will come up with some good number. So thank you. Thank you.
Thank you, sir. Moving on, I request Professor Ganpati Panda, sir, former Deputy Director, IIT Bhubaneswar, to please address the audience.
Good afternoon to all of you. Professor Narayan Padi, Director of MNIT. Professor Bhargav, Head EC, other associate professors. Thank you for giving me this opportunity. The theme of the 2 weeks FDP is on advanced optimization techniques. Today, optimization is not limited to computer science or electronics engineering. It is being used by all disciplines, engineering, science, management, and so on. Optimization was there since beginning. Optimization techniques previously was being used by statistical people, people from management, people from mathematics. But we are not only using this optimization for either maximization or minimization. It is being used for solving many decision-making problems. It can be single variable optimization or multivariable. It can be single objective optimization or multi-objective optimization. It can be with constraint or without constraint. So therefore, this multi-objective, multivariable, multi-constraint optimization is very difficult to solve by conventional methods, statistical methods. So the new techniques of optimization has come into picture. That is biologically inspired technique or nature-inspired technique or evolutionary computing-based optimization. This is population-based learning. Conventional method of optimization has a tendency to fall to local minimum. But these types of techniques try to avoid that. We talk about data science. There are about 7 to 8 types of various applications that is being used by all community of engineering and science. Forecasting, prediction, that is same classification, clustering, direct modeling, inverse modeling, detection. For all these applications, we use this advanced optimization technique, which is population-based. All these details I'll be speaking soon after the inaugural function. I thank MNIT Jaipur, the head of EC, that I am coordinator Dr. Nanda for giving me this opportunity. I request the various participants that this talk will be highly fundamental and a lot of potential applications of these techniques will be highlighted in my talk. Thank you.
Thank you, sir. Now I request EICT Academy IIIT DM Jabalpur, Professor Aparajita Ocha, to address the audience. Over to you, sir.
Madam Oja, are you there?
I request Dr. Bharat Gupta, CI EICT Academy NIT Patna, to address the audience. Over to you, sir. Moving on, we come to a very auspicious part of our program. I request Professor Narayan Prasad Padhi, Director MNIT, to please address the audience.
I think this is enough, no? Yeah. First of all, a very good afternoon to all of you. And as I've been told that there are close to 300 people attending this FTP. And very, very interesting about this program is one way we are talking about optimization techniques, and you call it is advanced optimization technique. So I'm very sure that we are not talking about, anyway, we'll be talking about the basics, but we'll be slowly getting into optimizing large data sets and huge multivariable, multi-objective optimization problems. So when you talk about hands-on experience with MATLAB and Scilab, though you must have certain impression about MATLAB and Scilab, but just you can talk and discuss next year. Probably we can also include some of the case studies through game software and other optimization tools. All right. So today there is a difference between MATLAB and other optimization tools, because MATLAB will give you solutions, but those solutions cannot be interfaced with online hardware applications. So that is where I'm thinking probably you can explore more appropriate tools, including MATLAB, where actually online optimization, whatever the solution that is available to you through your optimization technique, can directly get into a network level or a hardware platforms. So to me, I will like to give a small example for all optimization aspiring participants here. Now today, the optimization problem is altogether different the way we have been taught or we understood before 2 decades. Through this opportunity, I think Dr. Nanda is helping me to go back to my 3 decades of optimization, where I started my career actually with optimization a very long back. Rajesh and others must be knowing it. Professor Panigai, Professor Ganpati Pandaji must be knowing it. So initially I was very fond of optimization and loves mathematics a lot in my initial PhD career. The one thing, the way we looked into optimization is a basic Laplace optimization or a conventional optimization. But today they talk about vector optimization, means it is not even a one variable, but that variable become dependent on multiple variables. For an example, when you talk about energy today, energy means not electricity. Energy means heat, energy means gas, energy means electricity. So try to understand when you optimize your electricity, you can optimize gas, you can optimize mechanical energies, you can optimize heat energy to flow in the pipes. So one variable may disturb many other variables. So just imagine the kind of complications one has to undergo, especially engineers, those are working in industry. So I cannot simply optimize a local optimization point and get satisfied, whereas that may hamper some of the optimized variables that I'm looking for. So to me, few large case studies with wonderful tools where big data and vectors of variables can easily be solved. Nevertheless, now what happens today when we go for any such FDB programs, we are excited to get into research problems, but I'll be very happy if some of you can talk about Jacobians, someone can talk about Newton-Raphson methods, because they're all fundamentals we have studied during first year, second year, but by this time actually we might have forgotten. So it is nothing wrong, as Professor Panda mentioned, that it is better to get into the fundamentals, be strong in the theory, and then you go for the application sides. One more important point, I'm very happy to see, just I was talking to Dr. Nanda before coming to this room, how someone had patience to listen to you for 12 days. All right. So then he has mentioned, because normally, students today, they're annoyed with us for more than an hour of talk, okay? But controlling someone for 2 weeks is a big challenge. But the kind of expertise we do carry, almost 23 odd people, and it is not MNIT. I want to thank in specific to people from actually IIIT, DM Jabalpur, as well as NIT Patna. So it is a wonderful collaboration activity. So I do appreciate MNIT Jaipur is not really taking the lead, but also looking for opportunities to collaborate with team members from other institutions. And I'm very happy and confident that in future probably MNIT can explore more possible collaborations time to come. Professor Bhargav, is it fine? Very good. And now one more important thing I like to highlight here, that there are two speakers from industry. The first one is actually is a data scientist, and the other one is a graduate engineer. I think that number should increase. I think to me, instead of 20 academic people and 2 from industry, if you can make it at least 10-10 or 12-12, okay? So the industry can participate, or especially the experts can increase. That can motivate our younger undergraduate, postgraduate, and PhD students to contribute much more. Because we do carry a specific type of experience that is limited to books and problem solving. Whereas, industry-based optimization tools, if you can connect someone actually who can really help, and especially you can hire some data scientists from, top universities from North America, or maybe even from Indian institutions, those who can discuss something about few case studies which are very important, and maybe some banking sector people. And today people are talking about quantum optimization. Today people are talking about actually big data optimization. People are talking about actually, neuromorphic optimization. The things are altogether different. It is not limiting to artificial intelligence or data science, but it is much beyond it, okay? So probably I'm confident I wish you all the best, the complete team, for planning such a wonderful package for undergraduate, postgraduate students. And I could see huge, almost 30 to 40 odd students and young faculty colleagues around us. So probably please take maximum benefit out of this program. And I want to once again wish to thank all the collaborators, expert lecturers, industry participants, and all the candidates, those who have registered for this course. And probably 298 seems to be a big number for my colleagues, but I am not very satisfied with 298, because having an online platform, this figure should have crossed at least 1,000. The reason being, this is such a common course, common for everyone. So probably next time let us target 20 experts, 10 from industry, and 1,000 participants, with 4 to 5 institutions collaborating together. Okay. So with this note, I do not want to take a lot of time, because inauguration could have been a little formal, but it is good that we understood the kind of views of each and every experts. So with this note, actually, thank you all, and I'm very confident the kind of expertise being brought by MNIT Jaipur for this training program will be certainly beneficial, and see to that, you take maximum benefit out of it. Now, there's one point that is going on in my mind from the beginning of this inauguration, when Professor Labh Bhargav has, very humbly said that, MNIT Jaipur is at rank 46 and so and so. I think all my participants, you will be very happy to know that MNIT Jaipur faculty colleagues are extremely motivated towards undergraduate teaching. And this training program is one such example. So we like to conclude that perhaps we need to move very seriously towards publication and other vectors that decide the institution ranking. But I'm very confident that for Northwestern region, MNIT Jaipur is the first choice for all undergraduate students. I'm confident that we'll do much more in future, Professor Labh. Very good. So thank you very much and wonderful. All the best to all of you. Thank you.
Thank you, sir. We hope that your insights and experience would help us in the future. To mark the event, to mark today's event, I would request Dr. S.J. Nanda sir to present a memento to our guest, Professor N.P. Padhi sir.
This is not needed actually, but anyway. So, thank you.
Thank you, sir.
Please.
At the end, I would request Dr. Ila Sharma ma'am to present the vote of thanks. Over to you, ma'am.
Thank you, Akansha. Good afternoon, everyone. It has been such an honor to be part of this event. And on behalf of this FDP AOT 2020 and EICT Academy MNIT Jaipur, I extend a really hearty vote of thanks to our director, sir, Professor Narayan Prasad Padhi, sir, who spared time from his busy schedule to grace this occasion. Very hearty vote of thanks to Professor Ganpati Panda, sir, Professor D.K. Panigrahi, sir, Professor Prashant Jain, sir, Professor Praveen K. Padhi, sir, Professor J.P. Singh, sir, Dr. G. Pradhan, sir, and all of the faculty colleagues who joined us online and offline here. Thank you all for accepting our invitation. And today we had an opportunity to hear your all thoughts, and this will surely going to encourage us in our future events. I would like to extend my heartfelt gratitude to Professor Labh Bhargav, sir, Professor Vidit Sahula, sir, Professor Rajesh Kumar, sir, and all faculty colleagues for taking the time to be with us today. And at the end, a wide round of applause and thanks to all the participants and the students who made this event a memorable one, and wish you all happy learning. Thank you once again. I request everyone present in the room to please join us outside for a cup of a tea. This session will be followed by a keynote talk by Professor Ganpati Panda, sir, and on evolutionary computation. You all are requested to stay on the same link for the session. Thank you.
Announce the time. Just 4:25. Announce the time.
Let's have a 5-minute break.
4:30.
Start a keynote session.
Yes.
So I request all the participants that you should all connect with us with the same link for session
In the same
in the same link.
5 minutes, we are joining.
We are joining after 5 minutes of break.
Thank you. Thank you.
Ganpati Panda sir, namaste. Can you hear me? Namaskar sir. Sir, I am giving you the rights to present this presentation. Please check whether you are able to present your screen or not. Yes, sir, it's visible.
Right.
Yes, sir, we can start, sir. Over to you, sir.
Yeah. Thank you, madam. Thanks. So, thanks all the participants. My talk will be on evolutionary computing. I'll give an overview. Let me clarify from the beginning. Anybody who wants to learn more on this topic, please contact me later on through mail, because I am giving an overview. So I'm not going to the details, but our group has worked extensively in this area. Please see. Till date, there are about 40 algorithms. Let me tell something. This, why it is called evolutionary. If you see, our previous generation were monkeys, and then slowly we become human beings. So this is evolution. So as the time passes, there occurs a lot of improvement. So the evolutionary algorithm basically based on survival of the fittest, Darwin theory, survival of the fittest. The other name of evolutionary computing, other name, evolutionary computing, evolutionary algorithm. It is also called bio-inspired technique, biologically inspired technique, or nature-inspired technique. These types of name, why it has come? Basically, if you look to all these algorithms, one minute observation that small animals, insects, how they cooperate amongst themselves to survive, either during their good time or their bad time. When some enemy attacks some animals, birds or insect, how do they behave? When they get some food, how they share their food. Both in the good time and bad time, they unite themselves. Insects, birds, animals, fishes, any insects, even your ants or bacteria. These types of techniques are essentially based on population-based learning. Let me clarify why. the population-based learning is so popular. There is always a set of solutions. We know from statistical techniques that if you start any optimization with a single solution, there is a chance that you may fall to local minima. What is local minima solution? And what is global minima solution? That is, you get a solution, it looks like that you have got a very good solution on optimization. But that solution is not the optimal solution. That solution is not the best solution. Either when we say it is optimization, it is either maximization or minimization. So when you are not getting the correct solution, but it looks like it's a correct solution, that is called local solution. It has been observed, it has been found that this evolutionary algorithm try to provide global solution. But let me clarify, let me make it clear that none of these techniques, about 40 techniques which has come, there is no mathematical proof. There is no mathematical foundation that it falls to global solution. It doesn't fall to local solution. In practice, it happens. It starts with a set of solutions, and these set of solutions combine amongst themselves to get the best solution. Population-based learning has some disadvantage. One of the greatest disadvantage is it takes a lot of time. We get global solution, we get the best possible solution, but it takes time consuming. So when you want online solution, it is difficult to use population-based learning like biologically inspired technique, nature-inspired technique, or evolutionary algorithm. However, I'm telling many of the research problems. Convergence analysis, mathematical analysis, partially have been done for genetic algorithm and PSU, but it has not been done for other algorithms. So there is a lot of scope of research on the mathematical modeling, convergence analysis of these algorithms. The second one, today, population-based learning to reduce the time of execution. Distributed evolutionary algorithm has come into research. Many research are not many research papers, but distributed learning, when applied to evolutionary algorithm, I think that will be the future. Instead of 50 population to solve in a concentrated place, the population will be diverted into few groups, subgroups of 4 or 5. All of them will make partial solution with less number of population. And their solution is to be united judiciously, homogeneously, to get the final solution. Anyway, try to remember right from the beginning, I'm telling the research problem. Distributed evolutionary algorithm or distributed biologically inspired technique is the future to solve the problem. The second challenge is the convergence analysis. Why it works? Why it gives the solution better than the other types of solution? Okay. During the course of my talk, I'll just highlight these few algorithms. There are 40. It is not possible to cover in 1 hour. I'll give few of them, like genetic algorithm, differential evolution, bacterial foraging optimization, cat swarm, fish swarm, particle swarm optimization, and harmonic search. One more thing, I make it clear. Today, most of the research in whatever discipline, please do not mind that they are trying not to understand the basic internal algorithm, the steps. They try to use as a package. What is the problem? They are getting solution, papers are published, people are getting PhD degree. Unfortunately, I'm not telling all. Some of them are not understanding it. It is danger. You cannot modify algorithm. If you understand genetic algorithm, I'm sure you can publish a paper on GA by suitably modifying the internal thing to make it more efficient. So my submission and my appeal to all of you who are hearing the lecture, try to understand the inside of the algorithm, which are not happening nowadays. Now, genetic algorithm started by Holland 1975. It is an old algorithm. It is based on Darwin theory. And this genetic algorithm, reference paper I have given, genetic algorithm is of two types. Genetic algorithm of two types. First one, it is binary coded gene. Second one, the real coded gene. What is the difference between the two? Each of the solution, which is known as the chromosome, is represented in binary domain, either 1 or 0 form. These types of solution is more accurate. Binary GA provides accurate solution, but it consumes more time. Again, I am repeating, binary GA is time consuming, but gives more accurate solution. Coming to real coded GA, solution is not that accurate as GA. You get appreciable good solution, but it is much faster, 8 to 10 times faster than binary GA. So you have to make a compromise depending upon the type of application, whether it will go for binary GA or you'll go for real coded GA. This, before I go deeper into this, let me tell one thing. Y equal to sin x. Y equal to sin x. X is one solution. Y is the fitness value or the output value. I have to maximize the value of Y or minimize. So optimization means either you are maximizing or minimizing. Depending upon the value of X, which value of X? What is this? Sorry for the interruption. Basically, this genetic algorithm comprises of four things. First one is inheritance. Second one is selection, mutation, and then crossover, and then final selection, and you go to the next generation. Now, if Y equal to sin x, x is called the variable. Here x is one variable, but when I will write y is a function of x1 and x2, x1 and x2 are two variable problem, two variables. It can be multivariable. It can take hundreds of variables. Now, if x1 lies between 0 to 1, x2 lies between -5 to +5, if the range is given and you are trying to find out the maximum value or the minimum value, in that case, that is called constraint optimization. Again, I am telling y equal to sin x1, sin x, for example. And again, y1 is sin x, y2 is e to the power minus x. So there are two functions, y1 and y2. In one case, it is sin x. Other case, it is e to the power minus x. Now, find out the value of x at which y1 is maximum, but y2 is simultaneously minimum. This is a two objective problem. Two functions, two fitness well, and this is called multi-objective optimization. Now, in the approach for multi-objective optimization, which has got a lot of application, the approach is different, particularly in the selection. The mutation, inheritance, and crossover remain the same. Let's see. The basic structure, you have to initialize the population. It's a population-based learning. You take more number of population. Usually, for less number of variables, we take around 40 to 50 population size. And that means each solution or each of the member of the population is called chromosome. And the set of chromosome is initialized either randomly or if it is a real value, again random number, and subtract 0.5 accordingly, you'll find the random real value. Random solution is taken. Then it is followed by selection, crossover, mutation, and followed by fitness evaluation until you get the best solution. Now, the crossover, there are three types of crossover. One type, single point crossover. Second type, 2-point crossover. Third type, multi-point crossover. When you go for multi-point or 2-point, when the number of variables are large and the number of variables are less, better to go for 1-point crossover. Why mutation is done? I'm telling you only those points where people are having doubts. Mutation is a process by which any of these solutions who are responsible to make it a local solution, those solutions are identified and those solutions are rectified. Those solutions are altered. Mutation has a probability whose value is very less. Crossover has a probability whose values are high. And these crossover and mutation try to change the chromosome. You start with a set of 50 different chromosomes which are the solution. But as you proceed, you'll find all solutions become same. And take any one of these solutions because all chromosomes will be same. And that is the value of x. Put the value of x into the function. You get the maximum value or the minimum value. This is the fundamental of the genetic algorithm. Coming to particle swarm optimization, it was Eberhardt and Kennedy in 1992. Paper I have given here. Now this is based on the behavior of the bird. Please see the various stages of particle swarm optimization. Remember, particle swarm optimization is real value. It cannot be binary value. You start with a set of solutions. Each of the solutions is called the position of the bird. And let me tell a clear-cut example. A set of birds are trying to find the food. They are flying. They are not flying together. They are flying discretely. Each of their position in time is called the position vector. All the position, if you put in a vector form, is the position vector. and each bird has a direction with which they fly. So that is the velocity vector. So a bird has two parameters, a position parameter and a velocity parameter. And these two parameters are changing. The velocity changes, the direction changes, obviously the position changes. So each bird, they have their own position, which is the solution. And this position, a bird's all previous positions are recorded. And any given time, the previous best position and the present position are compared. Whichever is the best, that becomes the P best. The particle best position is the best position of the bird so far achieved. Now, the position vector is updated. The velocity is to be updated. Velocity update depends on 4 parameters. Personal best of the each bird, the global best, and there are 2 C1 and C2 constants. These parameters are responsible to change the velocity of the bird. Once the velocity of the bird is changed, then the position is changed, because the position plus the velocity become the new position of the bird. Once the new position of the bird is obtained, then from among all the birds' position, because there are 50 birds, 50 new position, find out the best of this. For a maximization, you take the highest value. For the minimization, you take the lowest value. So first is velocity is update, then you evaluate new P best, new G best, then calculate the new position. And this go on changing recursively. And finally, you'll find the G best is the solution. Every bar started with different position vector. But after some time, you'll find all the bars has come to the food source, or they have come to the position where the enemy is attacking. And that is the solution. That is the value of x. Put the value of x into the function. You get the highest value or the lowest value. So G best is the solution. So here 4 things: position vector, velocity vector, personal best, and G best. This is one of the very powerful real coded optimization algorithm. Now this optimization algorithm being used because it is 10 to 20 times faster than the real coded GA. It is faster than the GA. Now, next one, and colonial optimization. It is very interesting. 1992, Dorigo et al. Published a paper. Let me tell the position. Now, these parts, these ants, start from the nest where they stay. They move randomly. They move randomly for what? Search for food. Now, initially their movements are random. But after some time, if one of the ants gets some food, it will be astonished to observe all ants go to the food source. And they follow one path, return to the nest, which is only the most single path, and that is the shortest path. Very interesting. Lot of transport problem, lot of communication network problem today, lot of solution in the smart grid problem, in 6G communication, and colonial optimization is a very essential tool for solving challenging problems. You see, I have shown some diagram. In this diagram, F is the food source and N is the nest. One single ant is moving. Now there are various paths I have shown. So people are going in the longer path, people are going in the shorter path. But after few iterations, after few time, not iteration, they follow a single path, and that is the optimal path. And colonial optimization is a very powerful algorithm for it is applicable in all fields, railway transport, our commodity transport, our communication channel extensively being used on the basic principle of and colonial optimization. Let's see differential evolution, 1995. Two things. In case of genetic algorithm, first is initialization. They are both same. GA initialize 50 solution. In case of DE, initialize 50 solution. But after, in case of GA, after initialization, you have crossover. And after crossover, you have mutation. But in case of differential evolution, after initialization, you have mutation. And after mutation, you have crossover. It is the reverse. Finally, the selection. Second one, GA can be binary, GA can be real coded. But in case of differential evolution, it is only real coded. And differential evolution is much faster than genetic evolution. 1997 paper I have given. I'll just tell you the basic principle. Please observe whether you are able to see or not. One thing, you have got a target vector. Each of the member of the solution, 50 solution you are taking. Each one is first one if you take, it is the target vector. When the second one is taken, that is the target vector. So I have given about 5 solutions, 6 solutions. And sorry, 6 variable. I made a mistake. 6 variable problem. Y is a function of 6 variable. X1, X2, X3, X4, X5, X6. And there are how many solutions I have taken? Number of population size I have taken is 6 bars. 6 population size. Now randomly choose out of 6. You randomly choose how many? 3. I have taken 3 randomly chosen. The first and second you take the difference. First and second. Randomly 3, 1 was chosen. First and second one, take the difference. This value minus this value, this value. You get a difference vector multiplied with f. F value is usually taken some value, for example, 0.8. So f is a value to be chosen between 0 to 1. Multiply each value with this value. And you got the difference vector. Each of the element of the difference vector is multiplied with f. You get this value. Then add each member of this vector with the corresponding member of the third vector. Because initially you choose how many? You choose 3. First 2 is taken difference. Multiplied with f. Add with the last value. You got a new vector. This is called, you start with a target vector and you got a new vector. Now these 2 vectors are kept nearer. Now go to the second target vector. Choose another 3. Take the difference. Multiply it with f. Add with the last vector. You get another vector. So for each of the target vector, you get mutation vector. This process is called mutation. So if there are 50 population size, then you get 50. There are 50 target vector, and you get 50 mutation vector. Now, this mutation vector and the target vector will cross over. Crossover, you will have a probability. You generate a random number. If the random number is more than the value you have, crossover value you have defined, if it is more than that, copy from the target vector. If it is the probability value is less, copy from the mutation vector. That is, let me clarify. For each target vector, there is a mutation vector. Either mutation vector is to be chosen or the target vector to be chosen depends on generated probability value. If that probability is high, choose from the target, choose the target vector. If that random probability chosen is less than the predefined value, choose from the mutation vector. So either of the two. Remember, in case of genetic algorithm, 2 children are produced at a time. 2 children. But in case of differential evolution, only 1 child. You have got a target vector, you have got a corresponding mutation vector. Either of the two, one is chosen, other is discarded. So if there are 50 target vectors and 50 mutation vectors, so one of the two target to mutation, one of the two values, one is chosen. And that is the final vector that you obtain. That final vector, you calculate each parameter, each target vector and the corresponding vector, crossover value, put into the function, which if it is a maximization, whichever is higher you choose, and if it is a minimization, the lower one is chosen. In this way, finally you get only one vector. One generation is over. Repeat the generation. That is how differential evolution works. It is one of the very powerful optimization techniques. Artificial immune system. 2002 is one of the very rarely people are using. But I advise that artificial immune system is one of the powerful algorithms for optimization. It comprises of initialization, which is similar to all types of optimization technique, population-based. It has a cloning and mutation. Cloning and mutation. This I'll explain you. Cloning and mutation. Please see, our body, right from birth, when a small child is born, a baby is born, our body is not immune. The child is not that much resistant to outside world, prone to having cold, prone to having any types of fever or smallpox or chicken pox and such thing. The body doesn't have the resistance potentiality. When, please see, when an antigen, this is a virus, when the virus attacks, our body slowly develops antibody. Initially, a new child doesn't have any antibody. Suppose after a couple of years, there are 4 antibody and any types of virus, the virus shape and size are different for different diseases. Now, antibody is stored in human being. So when antigen come, for say antigen 3, for example, from our stored antibody, which one is matching? You see, this fellow matches here. This fellow antibody which is there in our body, it doesn't match to any virus. Shapes are different. So this artificial immune system try to find which antibody matches with which antigen. The moment the one is matching is found, then cloning is done. What do you mean by cloning? You see, it matches. And then once it matches, then this fellow bind it and this virus is killed. No virus can come in. So because it is not one, hundreds of thousands of antibodies generated. Once matching is done, then you've got many such things. So any virus which come from outside are killed by the antibody. Very interesting principle. And this principle, after this is killed, then this is stored as antibody. Once you are suffering from smallpox, second time to be attacked by smallpox is less. Once you are attacked by COVID, second time to be infected by COVID is less because you have antibody. As soon as the virus comes, the antibody clones to large number and kill each one of them. Very interesting principle. There are 3 theories: danger theory, clonal selection principle, And this theory one has to learn. And my advice, if these algorithms are used for your research work, it will be highly beneficial for you. You can modify the algorithm. 2002, same year, bacterial foraging optimization is very powerful optimization. It converges fast. It gives the solution much faster than any of the algorithms. 2002 it started. If you look to this, can I give 1 minute break? Please look to it. 1 minute gap so that you can able to understand much better. Wait, yeah. Class. To message. Yes. Please set your mind to 0, 0 as if you have not heard anything. Please refresh your mind. I am giving some advice on bacterial foraging optimization. Bacterium, plural is bacteria. Do not commit any mistake. Bacteria are moving. What is the purpose of bacteria? What they move? They find food. How they move? I am telling a small story. Bacteria are moving. How they move? They move in one direction first. When they change from one position to another, they evaluate their potentiality. Whether the direction in which the bacteria is moving, is he getting more food or is he getting less food? When the bacteria smells in the direction, there are 360 degrees a bacteria can move. When it moves in one direction and the food density is slowly decreasing, then the bacteria tumbles. It changes the direction. It moves in one direction. When food potentiality goes on decreasing, it swims. It turns, change the direction. Again in that direction, it moves couple of times, and if the food value is decreasing, again it tumbles. And whole day and night, a bacteria does this. Finally, the objective is that you please see the flowchart. Evaluated the fitness value of the bacteria, say J last. It moves in one direction, then it tumbles. Change the direction. Evaluate it. And once it does, then find out compare with the previous position, previous solution and the present solution. If the solution is better, then the new solution goes to the old solution. Then it swims. Why swimming? A set of bacterium is moving. They move in a, not exactly circular, they move in a curved way. When the food source or density of food source is less, they divert. They diverse. A set of bacterium, they become far apart. When the food source is decreasing, they condense, they become nearer. So whether the set of bacterium will be closer or they will be far up, depends on this process of availability of the strength of the food source. And after some time, once they get sufficient food, then you can evaluate the health of each of the bacteria. What is their fitness well? And then they do selection and reproduction. It is a mistake, reproduction. What is selection? The bacteria, each of the solution, evaluate the fitness value, put them from highest to lowest, keep the first half, discard the last half. 50% of the solution is removed, which are poor solutions. 50% bad solutions are kept. Then the reproduction takes place. What is reproduction? That first half is duplicated. That is, the bacterium split into two parts. If 25 bacteria becomes 50 bacteria again. So population size becomes same. Then what happens? Then dispersal. What is dispersal? Elimination. That 50% discarding is called elimination on the right side. And what is dispersal? Dispersal is very important. Some of the bacterium leaves the place, go to a distance place. And in the distance place, two things may happen. If the food is more, they remain there and their population grows. But if the food source is not there, they die. So dispersal is two things happens. Either they get stagnant or they become weak. The purpose of dispersal is just like a mutation. The mutation possibility is to remove the unwanted solution which has the potential to fall to local minima. So dispersal also does the same thing. BFO is one of the very powerful algorithms. Then the cat swarm optimization, Pilli algorithm, 2007. Cat swarm. It is much improved version of PSO. I told in the beginning, PSO is very, very powerful. But in PSO, improvement has been made by following the behavior of the cat. A cat has, you might not have observed, a cat has two types of behavior. One is seeking, other is tracing. You, in your house or in your locality, might have seen there may be a cat. The cat will be hiding somewhere underneath a cot or somewhere some cloth is there below that he is hiding. As soon as you find a food source or if somebody start attacking, that fellow will run, and that is called tracing. Seeking is with his powerful eyes, the cat moves in all directions and see where the food source is. As soon as he find a rat or any insect, he starts jumping, tracing. These two behaviors are being exploited to develop the cat swarm optimization. Please see here. Initialize the position, velocity vector of the n cat. Now, total say 50 population, please see. There is a probability, we take around 0.8. 50 into 0 is 40. 40 of the cats follow particle swarm optimization. And 50 minus 40, 10 number of cats, they follow what? They follow mutation and cloning. What is mutation? Mutation means every 10 cats, because 10 had come to the left side, each of the 10 cats undergoes small change and then find out the best one. If suppose the third cat after mutation is found to be the best, that undergoes cloning. So copy them. So copy each of the cat into 5. Each of the cat is copied to 5. So number of cats become more on the left side. Now put them into the function. Find out the best solution. Keep 5 best solution and discard all. Sorry, 10 best solution, because 50 into 0.8 is 40. So 10 best solution is kept. And this 10 best solution is mixed with the 40 solution of the other side. Again, 1040 is divided. And this process is continued. So one is called, as I told, seeking mode, other is tracing. And remember, cat swarm optimization is much faster and more accurate. This I have explained you in this chart. 10 cat, 8 cat, 2 cat, I have explained this example. Fish swarm optimization. The behavior of the fish. 2002 by Leo Sao Quen. It mimics the behavior of the fish swarm, makes the global optimum solution appear to be. See, there are two opportunities. Once they get a food, they combine, they unite. If somebody try to kill them, they separate out. And these particular characteristics of the fish are being exploited to develop this fish swarm optimization in 2002. So they have searching, swarming, chasing, leaping. Leaping means going away by jumping, and then random. These are the various stages of fish swarm optimization algorithm. Harmony search. This is another very interesting 2001. Grimm, Langathon, phenomena mimicking algorithm. Now, this harmonic search, phenomena mimicking algorithm inspired by the improvisation process of musician, they learn. If there are 10 musicians, their way of playing and the quality of the reproduction are different. Now, in this HS algorithm, each musician, that is each of the solution, decision variable, generates a node. The produces a node, but that node is not qualitative. Somebody might be very qualitative, somebody is poor. That is, the solutions are different. Each node is the solution for finding the best harmony, the best frequency component combination gives the global optimum. If not, they change. And this is one of the very simple, but this is not based on biological insect. This is not based on any animals or birds. But this is one of the very interesting optimization algorithm. It has random playing, memory consideration, pitch adjusting, then ensemble consideration. And these are the various steps of harmonic search. Now the advantages, as I told, of this biologically inspired technique are derivative free learn. LMS, least mean square algorithm, those have used, or recursive least square, or backpropagation learning of neural network are derivative based in the sense that you take the differential to get the learning equation. Differential, first order derivative. Now, when any derivative algorithm, there is a chance of falling to local minima, provided the problem is a multimodal problem. For multimodal problem, it is impossible to use the derivative-based learning to get the solution. And to alleviate this limitation, population-based learning has come into rescue. But as I told in the inaugural session, that these types of algorithm are time-taking. These type of algorithm, there is no mathematical, and these are the future research problems. So takes more time, no mathematical formulation, difficult for parameter, which parameter, how to set the parameter to, proper choice. There are 40 algorithms. Which algorithm to use for your solution? These are many of the difficulties. Multi-objective, there is no time for me. Multi-objective optimization is very, only remember out of maybe 40 algorithms, perhaps I could have spent more time on this. Fundamentally, multi-objective optimization, only for 10 or 15 10 or maximum 15 evolutionary computing algorithm has multi-objective optimization. Others are single objective. However, a multi-objective optimization can be solved by single objective optimization. For example, by taking this lambda 1, lambda 2, lambda. These are many objectives. You combine them to a single objective. But unfortunate part, how to find the value of lambda 1, lambda 2, lambda 3, and so on. And this is hundreds of combinations, and it's very time taking. To alleviate this problem, this multi-objective optimization came. And our Kalyan Mahadev and his 2B tech student in IIT Kanpur, they gave this NSGA2, non-dominated sorting genetic algorithm. And these types of algorithm, your two objectives are there. So you get both objective X and Y axis if you take for the same problem, you get a solution, and that it is not a single solution, you get a set of solution, and this curve is called Pareto optimal curve. Unfortunately, there is no time, so those who are interested, they can contact me. I can explain them. Here you have to learn something on convergence and diversity. And this Kanpur, as I told in 2002, there is a genetic algorithm lab. Now Professor Dev is in US, now not in IIT Kanpur. And this solution, you start with a random solution, but finally you get one solution like this. And this solution is very interesting. Similarly, there is multi-objective particle swarm optimization. Principles are different. These are many of the problems on multi-objective. This is one objective, this is one objective, and there is a constraint. And these are standard benchmark problem. And this problem you can solve. This problem. We have used this problem for solving many of the real life. One of my doctoral students in IIT Roorkee, associate professor, work on NSGA2 sensor network wireless. Coverage is maximum, lifetime is maximum. Coverage is maximum. These are the two objectives to be fulfilled. How to deploy the sensors. We solve many of these types of problems. These are a list of publications of my group who have worked day and night, and they have published many papers. As I told, they can be used for forecasting, for classification, for clustering, for filtering, for direct modeling, parameter estimation, inverse modeling, and many types of detection and other such purpose. These are all SCI journal paper, all SCI journal paper. We have used in almost all fields. So there are about more than 100 journal paper SCI on optimization technique, including our one of the coordinators of this program, Dr. Nanda. He has worked, he has done his PhD under me, and we have published many papers along with him. He has worked on geophysical various research fields. Some of his paper I'm seeing.
Sir, we cannot able to see you. Can you?
Paper. So basically, we have produced something.
Ganapati Pandit, sir.
This is one SJ Nanda is here.
Sir, please make your video on.
Not visible.
Ganapati Pandit, sir. So kindly make your video on. Sir, sir, Professor B.K. Panigrahi, sir, is there.
Thank you. Yeah.
नमस्कार सर. पंडा सर नमस्कार. शायद प्रोफेसर नंदा ऑडिबल नहीं हो रहा है. ठीक है.
Sir.
Yeah. In fact, I have concluded. If anybody quickly, because I have got another lecture for we should soon after this within 2 minutes.
Sir.
So,
Sir,
Professor
Professor
Panigrahi,
B.K. Panigrahi,
is
sir, will.
outstanding speaker. He has done a lot of research, quality research. I am
Sir, it is because of your
far
blessing.
below him. He is an outstanding
sir.
speaker, researcher.
Sir, please.
So I request Professor Panigrahi to continue. I am telling on behalf of Nanda.
It's a pleasure.
So it is my pleasure to welcome Professor Vijay Ketan Panigrahi sir. He is currently a professor with the Department of
Professor Nanda,
Electrical.
sharing facility is not active for me.
Sir, I am giving you the sharing face.
Yeah, take it.
Sir, Professor Vijay Ketan Panigrahi is currently professor. Just make the sound low. Is currently the professor with the Department of Electrical Engineering, IIT Delhi. He is heading the Center of Automatic Research and Tribology at IIT Delhi. He received the PhD degree in Power System from Sambalpur University, Bulla, India. He is currently the associate editor for IEEE System Journal, IIT Smart Grid, editor for IIT Journal of Research. He has written near about 400 journal articles, 300 conference proceedings, and 12 book chapters, and 7 books, which has received more than 12,500 citations with H index 65 and I-10 index 286. He is one of the top 2% researchers of India in this particular field of research. His research interest includes soft computing, signal processing, power quality, renewable energy systems, power system protections, and electric vehicles, charging infrastructure, cyber security of power system, and IoT. He is one of the very popular teachers at IIT Delhi and all across the country. So with this brief introduction, I request sir to start his lecture. So over to you, sir. Namaste.
When I share, is it visible? But when I share my slides, actually I could not hear you. Let me share my slides again.
Okay, sir.
Yeah. Is it visible and audible?
Yes, sir.
But I am not able to listen. Just if it is visible, just put a thumb.
Yes.
It is audible also?
Yes.
Okay. I am not able to listen all of you. Anyhow, thanks Professor Nanda introducing me, and I am really fortunate to give this talk on the particle swarm optimization after a great talk by my teacher, Professor Ganapati Panda, who is supposed to my PhD guide. And where am I is because of Professor Panda and Professor P.K. Das. Both of them are the veteran and my guide. So it's a great moment for me to carry on whatever Professor Panda has highlighted about all these algorithms. So 1 hour I will distribute accordingly. Let me first tell you what is the optimization methods. Because you see, this optimization method is tackled by the mathematician by various traditional optimization methods. There are mathematical programming based approaches to solve an optimization problem. Similarly, there are also non-traditional optimization methods. So if I'll categorize these two, traditional, which is based on certain rule, certain law, certain mathematics. Non-traditional, no rule, no law, no mathematics, but it is a random. So I'll come into that particular one, and why this is necessary, I'll also tell you. So when I'm talking of the optimization technique, so what exactly we are trying to find out? We are trying to find out a possible solution in the search space out of the n possible solution. For example, you want to travel from particular point A, let us NIT Jaipur, to another point B, which is maybe your airport. So if you want to travel these two distances, there are many routes. You may go in n number of ways. So n number of ways are n possible solution to the problem. But out of that, you have to find out what is the best possible solution. So please try to understand, when I'm trying to find out the best possible solution, it can be found out depending on defining the objective function. For example, if you want to define the objective function, I have to travel from point A to point B, but it should cover minimum distance. I am not bothering. Even the distance is minimum, it takes maximum time. So ultimately, you will find a minimum distance path. But somebody may think, no, I want to travel from point A to point B in a minimum time. It may be, distance may be more. Okay, so that's why please try to understand, when you are defining a problem, you must be sure about what is your objective function. What exactly you are trying to find out of the n probable solution. So the best solution you can find out by a search method. So whether it is an optimization, it is a search method. So if it is a search method, if an optimization method, you can find out this solution either by a deterministic algorithm or by a stochastic algorithm. So these are the two main classified algorithms maybe Professor Panda had pointed out. Now, why this evolutionary computing? Why this bio-inspired computing? Why this swarm intelligence? Why this natural computing? See, bio-inspired computing, natural computing, these are the classical way how you follow the nature, how you follow the biological inspiration to find out the optimization problem or to solve the optimization problem. This can be done with two ways. One is the evolution process, which is genetic algorithm, evolutionary algorithm. Another is the swarm intelligence process, which is basically, so these are the two broad categories, evolutionary algorithm and swarm intelligence based algorithm. Swarm intelligence based algorithm are basically, if you know that swarm is a collective noun, which we have studied in our English literature in class 4 or 5. So how a particular task, how the particular optimization problem can be collectively solved by n number of agents rather than solving it by a single agent. So when I'm telling this, the problem will be solved by n number of agents. So each agent in the search space is a probable solution in the search space. All those agents, they coordinate among themselves how to proceed towards the global solution in the search space. That I will explain by means of the particle swarm optimization. Now the question is, what is the demerit in my deterministic algorithm? So I am interested to go all this algorithm, because please try to understand, when you try to communicate a research article, please write this, there may be various background of yours. Somebody may working in power engineering, somebody may working in communication engineering, somebody may working in mechanical or whatever. So you have a problem definition. Now look into your problem. Then looking into your problem, you have to find out a solution methodology, which is the optimization method. So which method you have to adopt, whether it is a deterministic algorithm or it is a non-deterministic stochastic optimization technique. So this will be decided based on the nature of the problem. I don't require a talwar to cut an apple. A small knife can do this. So please, why I am telling all these things to you? Because as a researcher, you must able to justify the particular algorithm you are using to solve the problem. Problem is yours. You are the expert in your problem. But as an expert also, you have to decide which algorithm is best suited to my problem. Because just now Professor Panda has categorically told there are n number of algorithms. Every algorithm tries to find out an optimal solution. Then which algorithm is best suited to my problem? So that can be only judged by yourself, looking into the dimension of your problem, looking into the complexity of your problem, and most importantly, if you are choosing a particular algorithm, how you are tuning the parameters of the algorithm. Because Professor Panda has already explained many algorithms. You can't tell which algorithm is better. There is a classical theorem which is known as no free lunch theorem. So accordingly, you can't tell this is better or that is better. Now coming to my point, you require such algorithm for the multimodal function optimization. What is this multimodal function optimization? I'll just take 2 to 3 minutes, not more than that, because my main idea here is to make you aware why I am going for all these evolutionary algorithm or swarm optimization algorithm. What is the similarity among all the algorithms? You can see all the algorithms are similar to some extent. I'll tell you that. Now let us look into the first function here, the function which I am showing to you. Okay, so let us, the x-axis is a variable x and the fitness is f of x. I am evaluating the function f of x, and the x is the source variable. It is a single variable problem. So x stands for from x lower limit to x upper limit. So this is the function. I want to maximize this function. So when you want to maximize this function, the traditional way of solving this particular problem is, you know the search space range. So you know the x lower limit and x upper limit. Start from a particular point which is randomly selected. That is the initial guess of the solution. So if I am taking the initial guess of the solution x0 here, I am evaluating f of x0 here. Just a minute. I'll take pen. Okay. So let I am telling a x0. This is my initial guess of the solution x0. So once you are taking this x0, then next is evaluate the function f of x0. What is the next step? So remember, in this search method, which is basically known as Newton-Raphson method of solution, to find out the optimization one, okay, in a traditional method. So x0 is the initial guess of the solution. You know the function which you want to maximize or minimize. Evaluate f of x0. So this is f of x0. Okay. Now the next step is how to generate a new solution. The new solution is generated by incrementing the value of x0 by an amount del x. Now remember, this del x increment is a deterministic in nature. You decide what is the value of del x. Okay. So let x0 plus del x is the next solution. Okay. So a new solution is generated from the old solution in a deterministic manner, that is x0 plus del x. Now evaluate f of x0 plus del x. So now you have y2, y1. So take y2 minus y1 divided by x2 minus x1, which is nothing but del of fx, that is del y by del x, which is nothing but the information of the gradient. Okay. Look into the gradient. If the gradient is not 0, you increment x0 further, x0 plus 2 del x, evaluate it, go on and stop where the gradient is 0 and report this is the maxima of the function, because after that the gradient again decreases. So either it is a gradient ascent algorithm or it is a gradient descent algorithm. So this is a traditional sort. This is a deterministic sort. The number of agents involved in the search procedure is 1. You have only one probable solution at the starting. Then the search proceeds in a particular direction. The direction is the increment of x0 by an amount of del x, which is fixed. So this is a deterministic search, single agent search. But the point is, now wherever I am reporting this maximum, this is not actually the maximum of the function. Somebody may take initial guess here, because the initial guess depends on how you are choosing in the search range x lower limit to x upper limit. So the second person who has taken the initial guess here, he or she will report this is the maximum. This is also not. Similarly, if somebody takes the initial guess here, he or she will report this is the maximum. So remember, if I am solving this particular problem where there are multiple maxima, which is a global maxima, or which is known as a multimodal function, it has multiple maxima or multiple minima, finding the global solution by the traditional search method, remember, may or may not lead to the global solution, because you may trap at local minima based on the initial guess of the solution. So what is the way out? This is one way. So I can go here for a random search technique rather than a deterministic search technique. I will go here rather than a single agent search technique. I will go for the multi-agent search technique. So I will tell that multi-agent search technique is nothing but your evolutionary algorithm, is nothing but your swarm intelligence algorithm, or whatever. This is one way. The other way, for example, the function doesn't exist between this x value and this x value. So if the function doesn't exist in between certain values of the x, because in some practical problems, you may not get a feasible search zone or feasible solution for some value of x. Okay. So in that case, the function becomes discontinuous. If the function becomes discontinuous, then proceeding by means of the gradient information, the slope information may not give you the solution. So that's why if it is a multimodal problem, if the function is discontinuous, then we are going for the non-traditional optimization technique. So this is a traditional optimization technique. A single agent starts, proceeds with the information of the gradient, stop at. So why I am telling all these things? If your cost function, which you want to maximize or minimize, is a simple function, convex, simple. It has a simple one minima or one maxima. Please don't go for this evolutionary algorithm or any other algorithm, because the reviewer immediately will ask you, your function doesn't need such a tool. So that's why you have to be very careful when you are applying all these algorithms. Only to publish paper, just put the algorithm and find a solution doesn't carry any meaning. Okay, so please, that is my advice to the research scholars, those who are attending this particular class. Okay, so now coming to, these are the multimodal functions. You can see there are multiple minima or multiple maxima. This is the ACL function in 2-dimensional. Where I'm talking of the dimension of a problem, you know there is one variable x1, the other variable is x2, or one is x, the other is y, the magnitude is z. If it is, you can imagine up to 2 dimension, but if it is an n-dimensional problem, the function having n number of variable, and the function f is a function of capital X, x is a vector, and x has n number of variable x1 to up to xn, then you can't imagine it. So this may be a multimodal problem with n number of variable. So the challenge is there, and you can visualize this by simply, sometimes you may get angry. So if you get angry, take a paper, newspaper, crush it on your hand. Put the newspaper like this on the right side. You can find this is known as a crushed paper function, multiple maxima as well as multiple minima. So just to visualize what is the global optimization or what is a multimodal function. Okay. Similarly, if there are some people who have seen the egg crate, you can take a egg crate. Okay, put on in the hand the egg crate, fold it like this. If you fold it like this and look from the bottom, there are many minima. And if you fold like this in the downward direction, look from the top, there are multiple maxima. So this is a multimodal function. So what is the way out? In the multimodal function, to solve it, I need multi-agent. So in any of your algorithm, whatever Professor Panda has told, whether it is a particle swarm optimization, whether it is a GA, whether it is a bacteria horizon algorithm, whether it is an ant colony optimization, whether it is a honeybee optimization, whether it will be the spider monkey optimization or differential evolution or cat swarm optimization, don't bother. All optimization technique, whether based on evolutionary algorithm or based on swarm intelligence algorithm, the classic starting point is assume n number of solutions in the search space. And I will just compare here the traditional and non-traditional. Traditional algorithm, Newton-Raphson algorithm, assume one initial solution in the search space. Non-traditional algorithm, assume n number of solutions in the search space randomly. These n number of solution in genetic algorithm is known as, yes, each individual solution is a chromosome, and the whole solution, n number of solution is population. Each individual solution in PSO or each individual probable guess of the solution in PSO is particle, all solution swarm. So swarm in PSO is population in your genetic algorithm, is colony in ant colony optimization, colony in bacteria optimization, vectors multiple in differential evolution, bees in terms of artificial bee colony. I don't bother. Each individual solution is either a chromosome or a particle or an ant or a bacteria or a vector or a if it is a any other algorithm, your monkey, spider monkey algorithm, it is a spider monkey, it is an ant, it is a bee, whatever. I don't bother about that. So starting it said, I assume n probable solutions in the search space generated randomly. If you know the variable of the search space, okay, suppose the first variable lower limit x1 lower limit x1 upper limit, so generate a random number between that. Second variable x2 lower limit x2 upper limit, generate a random number between that. If it is a 2-dimensional search, if it is an n-dimensional search space, for all n number of variables, generate a random number within their lower limit and upper limit. This constitutes one probable solution in the search space. I hope you have understood. Once you take that, in traditional algorithm, once you take the solution x0, what is the next step? You are evaluating f of x0. So here, exactly the same thing. You evaluate all n number of probable solution in the search space. So f of the first particle, f of second particle, f of third particle, f of 20th particle. If the population is 20, if the particle size is 20, if the chromosome number of chromosomes are 20, if the number of vectors in differential evolution are 20, if the number of ants are 20. So you evaluate all. Here comes the difference. Once you evaluate everything, what you are doing in traditional algorithm, you take x0, evaluate f of x0. I am taking n number of x value initial, evaluate all. What is the next step in traditional algorithm? I generate a new solution from the old solution x0 in a deterministic way by adding a vector del x. So if it is a n dimensional problem, it will be x1 plus del x1, x2 plus del x2, x3 plus del x3, xn plus del xn, but deterministic. But here, as this is a stochastic algorithm, I will find out the next probable solution from the original initial solution, not in a deterministic manner, but in a random stochastic manner, which is purely dependent on the algorithm. If it is an evolutionary algorithm like GA, you generate a new solution from a set of parents by crossover so that you will get two offspring or two children. Clear? So similarly, in PSO, how it is generated? In artificial bee colony, how it is generated? In bacteria foraging, how it is generated? So generation of new solution from the old solution is dependent on each individual algorithm, but initial period is same. So now I will discuss. You can see it. They start. All these agents, they start. They communicate within themselves. They reach at the top, and the end, everybody is a winner. So I will discuss about the particle swarm optimization, which is one of the best algorithm as far as I know, and it has certain mathematics hidden out. I'm not going to discuss all these things because the swarm intelligence is basically the knowledge we acquire from the swarm. Many of you have seen the Discovery Channel. It is either the swarming of the fish in a group. So swarm means group, try to understand. Or it is swarming of the bee, or it is swarming of the birds which came from Siberia to India. You see, they don't have a compass, but how they adjust their velocity, they start at a particular time and reach at a particular time. That is the inspiration we are getting in solving a mathematical problem. Okay, so whether it is a termite swarm, so all these things, ant colony. So these are the different algorithms. I'm not going into the detail, but I will discuss you the particularly particle swarm optimization, which is mainly invented by Kennedy, Everhart and Kennedy. Everhart and Kennedy in 1995, and this was published in a conference in 1995. Then UEC is added. I am fortunate to edit a book with UEC, particularly the swarm intelligence and its application. And so this is the PSO I will discuss with you. I'm not going into the detail of the, these are the two inventors. Russell Everhart is an electrical engineer in Kansas State University, and James Kennedy is a social psychologist to find out. So that's why this gives the PSO is an interdisciplinary, or all these evolutionary algorithm I'm talking of are completely interdisciplinary in nature. I'm not going into the detail of this. I'll just tell you how I am getting a solution so that you can understand. So here, please try to understand. You have to remember, you have to take three different aspects. Okay, what are the three different aspects? For example, try to understand. You have n number of variables. For example, x1, x2, up to xn. So this is the n number of variables. Okay. Then one variable, suppose I will define I equal to 1 to n. That means, sorry, I will make a d the dimension of the problem, d equal to 1 to n. So this is a d-dimensional problem. So if it is a d-dimensional problem, what initially you will do? Maybe in a MATLAB program when people will explain you. So you generate an initial particle which is having d number of variable, d dimension, d number of variable, x1, x2 up to n. Okay, so total dimension is n. Now the next is, once I have a dimension n, so I take n number particle. Then next is, what is the number of particles? N. N equal to, let us 1 to 20. So here I can make ijk. So I is the dimension of the problem, j is the number of the particle 1 to 20, and k is the iteration, okay, which is 1 to 500 or 5000. So you have to make the difference. What is these three variable I, j, k? I is the dimension of the problem, the number of variable associated with the problem. That means this is a, okay, d-dimensional subspace if I equal to d. If j equal to n, that is n is the number of particle, total number of particle. Each particle d dimension, total particle 20. Okay, that means total probable solution in the subspace are 20. Now once I will assign this, I am evaluating this. Once you evaluate this, let the particle are evaluated at a particular iteration at the starting. Okay, so once they evaluate, so what you will do in the PSO, when you initialize, now you initialize 20 particle. So okay, you have 3 loops. Okay, I equal to 1 to D, J equal to 1 to 20, K equal to 1 to 500. If it is a D dimension, suppose I am solving a 5-dimensional problem. Okay, so I equal to 1 to 5, J equal to 1 to 20, K equal to 1 to 500. How will you start? So first you start for J equal to 1, you generate a random number x1 between x1 lower limit to upper limit, x2 lower limit to upper limit, x3 lower limit to upper limit, up to x5 lower limit to upper limit. So this is a particle having 5 variables, each variable having a lower limit and upper limit you generated, that is particle 1. Now your loop is 1 to 20. So you generate 20 particle. So now 20 particle are randomly generated. So every particle is given a dimension x1, x2 up to x5 within the range x lower limit to x upper limit. So I hope you have understood. Then similarly, each particle is randomly given a velocity. आप एक धक्का दे दो. So once you are giving it a random velocity, similarly the random velocity is having a range, because you know the minimum displacement from this to this velocity range is also this. It should not cross that. So every particle at starting is given a random position and random velocity. Once you give it, what is the next step? You evaluate. There are 5 variables. Maybe your function is x1 into x3 plus x2 x4 mod plus x5 sine x1, whatever. So you evaluate. You evaluate it for all the 20 particles. So once you evaluate it for all the 20 particles in iteration 1, you will know if it is a maximization problem, which particle is best. That is the topper in the class. Which particle is worst. So all the 20 particles have been evaluated. Among this evaluation, one is the best particle, which is the best performer. If it is an optimization problem, the maximum value is the best performer. If it is a minimization problem, the minimum value is the best performer. You get everything. What is the next step? How the particle will move from iteration k to iteration k plus 1. That is the main thing. So that's why if you understand this vector diagram, then you will be clear. So you see, S is the particle position at kth iteration. So here I am hiding 2 things. What 2 things I am hiding? It is the S of the particle I in dimension D. Because every dimension में you have to update its variable. x1 to next new x1, x2 to new x1, because the particle is having 5 variables. So when you get the new position of the particle, x1 will be updated, x2 will be updated, up to x5 will be updated. Let me tell in this room. So I have a particle here which has a x coordinate and y coordinate. Okay, x coordinate and y coordinate. Based on this, you have get a z evaluation. Now when this particle will move from this point to this point, now there is a change in del x1 and del x2. So how to achieve this? How to change this velocity, new velocity? So that's why this is very important. S is the position of the particle at which particle? Ith particle. In which dimension? D dimension. So every dimension में, so एक loop रहेगा D equal to 1 to 5. Every dimension में आपको update करना पड़ेगा for particle I. Then I will be updated from particle 1 to 20. Now you hope that. In a particular iteration k, then k update हो जाएगा 2. So inner loop, then next outer loop, then finally another outer loop. So 3 variable, I hope you understand. So now if this is the position of the particle and how this particle has come here, it has come here. Which particle? Ith particle. Which dimension? Dth dimension. Okay, with a velocity VIK. So if this is the velocity of the particle, I will not change the velocity. It will go straight and hit the wall. It may not go to the maxima. So here comes the psychology. I will give you a simple example to understand this psychology. Let us, I have 20 students in a class. Clear? So if these 20 students are in the class, j equal to 1 to 20. They are taking 5 subjects. So dimension is 1 to 5. And I assume that these 5 subjects will be taught to them in all 8 semesters. So k equal to 1 to 8. So you hope understand. There is a class. In the class there are 20 particles, 20 students, j equal to 1 to 20. They take 5 subjects in every semester, maybe with a higher order. Okay. So dimension 1 to 5. k equal to 1 to 8, 8 semester 4-year course. So now suppose you are at k equal to 3. If you are at k equal to 3, so all the particles are at the third semester and all the particles are given the exam. You have mark of all the particles in all 5 subjects. You add up this, evaluate it, the marks. Once you evaluate the mark, you will know who is the best and who is the worst. But what is the main idea? The idea is at the end of the 8th semester, that's why I have taken my k equal to 1 to 8. My search will run for 500 iteration, k number of iteration, k number of steps, and I will terminate the search there. So at the end of the 8th semester, every student want to be a topper because they want to be the global leader, global maximum. So what these students will do? If I will ask these psychological questions to you, then definitely to each individual student, by abhi aap you are at 3rd semester, k equal to 3. You are 20 students, but unfortunately one is topper. Then what will do to you to become the topper? So I am asking this question, I equal to 10, the 10th student whose position is now 10. Let us. What you will do? So definitely he will tell, I will try hard. So if he is trying hard, then definitely I will remind him, your position is 10th at this particular time. Have you ever been performed better? Look into your past. You maybe your position was 4th in first semester. Oh, he may recall, yeah, my position was 3rd in first semester, but unfortunately this semester my position is 10th. So what he or she will do? So definitely they will try, they will look on their previous history, my personal best. So the ith particle here is looking into its personal best. His personal best velocity was VP best. His present velocity is VK. Now he is in a dilemma whether I am reading 5 hours when I was in class, semester 1. At present I am reading in 3 hours. So I want to minimize that. So he may look into the other. So this is known as self-cognition. Yes, I can do. I can become the topper because I have neglected something. I will proceed in that particular direction. The other social effect is ask to the topper. Somebody the global best. How many hours you are reading? He must tell you the truth. Yeah, I am reading 10 hours. So his position, his velocity is VG best. So the PSO is completely governed by a psychological phenomena. What is your present velocity? VK. What is your previous velocity? VP best. What is the present best velocity in the group? VG best. So I will take these 3 vectors. I will make some manipulation of this vector. I will give weightage to each individual vector to find the new velocity of the particle I in d dimension, that is Vk plus 1. So neither I will take Vk, nor I will take Vp best, nor I will take Vg best. I will take a weighted sum, okay, of these 3 vectors. One is my own acceleration, that is Vk. One is my previous best, that is self-cognition, VP best. Another is social interaction, that is VG best, because I'm depending on the topper. So these 3 vectors is added mathematically as well as vectorially to generate the new velocity of particle I in dimension d. Again, remember, you have to update in every dimension. So the one particle position will be updated once you update all the dimensions. So for I equal to 1 to 20, inside it will d equal to 1 to 5. Again, on the outer side, it is your k number of iteration is 1 to 500. I hope you understand it. So these are the just addition of those vector I am showing to you. I am not going into. So what happens? Each particle tries to update its position based on its current position, which is Vk. Based on the current position is Sk. The current velocity Vk. The distance between the current position and personal best, that distance. So P best, which is the previous, minus Sik, the present, and the distance between the current position and your global best, the topper. So you see this mathematics. No problem. At least one simple equation you write in MATLAB, you will get the solution, or you write in Python, you will get the solution, or you write in your Scilab, you will get the solution. So remember this equation. Velocity of ith particle in the dth dimension in k plus 1 iteration is velocity of particle I in the dth dimension at kth iteration with a weightage omega. So this omega is known as acceleration factor, acceleration coefficient. Okay, so you try to control own velocity. Then Sik is my present position. P best I it is my best position. So I means my best position. The difference multiplied with a random number phi 1. So you can have a C1, generally in some paper C1 is constant 2.1, and you generate a random number between 0 to 1. So basically phi 1 will be 0 to 2.1. Similarly, you take the difference G best, the topper, minus my position SIK multiplied by another function phi 2, that is C2 into ran 2. C2 is a random number, and C2 is a constant, which is generally in the 1995 paper, Everett and C or Everett and Kennedy, they have taken 2.1, 2.1. Okay, so you will get the value of phi 2. So the whole algorithm is basically governed by the position of the particle at the next iteration to generate a new position from the old position based on the social behavior and the self-confidence. Okay, so that's why this is the main thing, the modification of the particle. Okay, so coming to this, I have just represented in vectorially. You can see this is the position of the particle x1, particle 1 at a time period t or iteration k, up t or k. So here what happens, the original velocity is the black, similarly second original velocity is the black, the personal best is this direction, the g best is this particle. So you take the vector addition of the black one, this dotted blue one and the pink one, you will get the new velocity. Similarly, here the pink one, the dotted one and the black one, you will get the new velocity. So x1 changes its position next iteration to here, x2 next position to here. So this has shown to you by a simple diagram animation. This is available in the website where you can take. See what exactly I am doing. I am taking the x1 lower limit, x1 upper limit. Similarly, x2 is another variable, x2 lower limit and x2 upper limit. So let us take an example. Let x1 lower limit is 2, x1 upper limit is 5, x2 lower limit is -5 and x2 upper limit is 10. So what I will tell to you, you generate a random number between 2 to 5, so that is 3. You generate a random number between -5 to 10, okay, that is -3. So this will be 3 minus 3, a position of the particle. So the first number 3 minus 3, that is the position of the particle, and randomly given a velocity in both the directions, x1 as well as x2. Similarly, all the particles are randomly generated and given a random velocity. They are evaluated. Once they are evaluated, you can find out the global best. Then definitely, this is the global maxima. This may evaluate the global best. Then based on that, you can see in the next iteration how the particles are moving. This is that iteration 1. This is that iteration 2. This is that iteration 3. This is that iteration 4. This is an interesting phenomena you can see. After certain iteration, some particles are trapped at local minima, because this is a local minima. This is another local minima. This is another local minima. But this is a global, either minima or maxima. So as these particles are trapped, but these particle movement are based on the information of the global best. So this global best will try to pull out all those particles towards that. So that is the beauty of this algorithm. That is the beauty of the social interaction in a when we are doing a collective search. So that you must remember, that is the beauty of this particle swarm optimization, where we are trying to find out the solution, okay, from this global best minus SIK. Clear? So ultimately, you can see at the end, every particle will converge to the same value. At the end k equal to 8, it may happen that all the 20 students will secure the same mark in all the 5 subjects if you add it. So that is the beauty of this algorithm. Everybody is a winner. But in the case of genetic algorithm, that is not the scenario. Okay, you have only one offspring which is better. You want to keep it. That is the elite preservation. But in the case of PSO, I am giving the chance to every particle to compete in the search space, and at the end, all is well. Everybody is the winner. Every particle will evaluate the same value. That is the global maxima, may or may not. that I can't guarantee. It may trap at some other, because that is the algorithm. So that's why you have to run the multiple times of the algorithm to see where it converges. Clear? So this is a simple example. I will share this slide. I am not going to discuss. This is like a function I have taken x to x minus 8. Please don't tell me, sir, why you are telling this function. This is a very simple function. If you look into this function, this plots, there is only one minima. Okay, if there is one minima, I don't require this algorithm. But for your understanding, just I have taken this function. Okay, so all the 4 particles. So here your dimension is 1, number of particle is 4. So all the particle are given a random position because the range is -10 to 10. You can see all are given a random position which is between -10 to 10. All are given a random velocity which is between -10 to 10. Then every particle is evaluated. If your x is 7, this is 7 into 7 minus 8 is -7. If it is -2, -2 into -2 minus 8, that is 20. If it is 9, 9 minus 8 is 9. If it is -6, -6 minus 6 minus 8 is 84. If it is a minimization problem, now which is the global best? The global best is this one. What is the global best position? The global best position is 7. So now the particle will update their position. All the particle, but unfortunately at the first iteration, the global best will not update. There will be no previous history. So it will remain, but all other 3 particles will update it without previous history. But after that, you will already get iteration 1. This is iteration 1, you will get iteration 2. So if I am evaluating it after iteration 2, they will evaluate. Now you see the new particle, new velocity is 1.5 and new position is 8.5. For particle 2, new velocity is 6.5, new position is 3.5, and I am evaluating the fitness. Now you see the particle 1, which was best with a position 7, you can see this position was 7. So this term is 0, P best term is 0, G best term is 0. For this also P best 0, but there is a G best because the global position is 7, its position is -2. So the first particle now evaluates 4.25, particle 2 evaluates -9.75, this is -8.16, particle 4 evaluates -15.91. So surprisingly, the particle 1 which was best in iteration 1, now particle 4 becomes the better because its evaluation is -15.91. So that's why you go on this for number of iteration and finally you will find out all will converge to this particular value. So this is a single dimension problem. Similarly, I have seen it for a Rastrigian function for a multi-dimensional problem. You can see there are 2 variables. The x1 is between -5 to 5, x2 is between -5 to 5. The phi1, phi2 value or c1, c2 I have taken 2, omega is 0.5. Okay, so this function is a Rastrigian function. This is the surface. You assume the initial position of the particle. You can see I have assumed the initial position of the particle. X1 is 0.85, x2 is 2.06, x1 is -2.17, x2 is -3.75. So these are the position of the particle. This is fifth particle, this is the second particle, this is the third particle, this is the fourth particle, this is the first particle. Okay, so all the particles are evaluated. Then you can find out which is the evaluate best. Then you go on iterating this. You will go on iterating this. Now you can see their position has been changed. 5, 2, 3, 4, 1. Remember, the earlier I am only updating only x1, one variable. Now I am updating both x1 and x2 variable. Okay. So if I am updating x1 and x2 variable, both one, then it is a minimization problem. So if it is a minimization problem, 90.79 is minimum. So this is the value. X1, X2 global best position. So once I update, now I am moving all these. So you can see those particles are moving from one point to the other point, and finally you will get the solution. I'm going not. This is your accurate function. So now the beauty, because I have promised to tell you if this is the first algorithm, people have worked on this first algorithm, then how will you modify this algorithm to generate a new solution? See, ultimately, generation of a new solution is by controlling. I will look into as a control system problem. If I look into a control system problem, those who have studied the mathematics, the state variable problem. Now you see, I can define 2 variables. One is the position, another is the velocity. If one is x, the other is x dot. And when I am talking of the movement of the particle from one position to the other position, is a dynamics. The change in the position of the particle, that is the velocity. And the time is one iteration. So remember, here I have a set of mathematical equation, vk plus 1. Okay, because I am writing this velocity at k plus 1th instant, vk plus 1 equal to omega vk plus phi 1 into some control variable p best minus sik plus phi 2 into something that is g best minus sik. And next I will get sk plus 1, the position, new position, is equal to sk plus vk plus 1 into time. The time is one iteration, that is 1. So these are the state equation. So ultimately, the movement of the particle in the surface is completely governed by 3 parameters, that is omega, phi 1, phi 2. or omega C1, C2. So how I will update those particles, how I will take the value of the particle, because if you look into the initial paper, phi is 0.9, C1 is 2.1, C2 is 2.1. But after that, there are many modifications of the algorithm. There are more than thousands of new algorithm, new variant of PSO have been established. And there is a beautiful paper by Passino and Gaji, where they study the stability of the swarm. Because when ultimately what happens? In the search space, the swarms are moving from one point to the other point and finally going to the optimization, to the global optima. So when they move, if I can make this movement a stable movement, a streamlined movement, so that my algorithm will converge to the final optimal solution. So the convergence and stability are the two problems which are associated with the control system problem. And in the control problem, the stability and convergence are dependent on the parameter. So if I can choose this parameter omega phi 1 and phi 2 very carefully, definitely I will converge to the global solution or near optimal solution. So that's why every evolutionary algorithm, every swarm intelligence algorithm are based on certain factors. So that I want to discuss. See, when I'm starting my search, basically I want to explore the search space. So if I want to explore the search space, that is a global search phenomenon. Now, as my iteration is coming closer, I am already explored. Now, finally, you want to trace towards the global or in and around the global. This is a finer search, which is known as the local search. So, the evolutionary algorithm must have the capability of the exploration, that is the global search, and exploitation, that is the local search. So, how I can tune the parameter so that the algorithm will have a better explorative capability at the initial stage and a better exploitive capability at the final stage. So I want global search ability in the starting of the iteration. I want a local search ability at the ending of the iteration. So for that, the best factor is omega, the acceleration. Initially, I may have larger acceleration. I may have large footstep to go on. But when I'm achieving towards my optima, I can't have a larger step. I'll take the steps very, very small. That is local. You might have tuned your radio. The Purana radio you want to tune, there is a lal stick. Okay, you want to listen certain radio station. So there are two tunes, fine tune and coarse tune. So initially you have the coarse tune, it will move faster. Then once you will move faster, then you have a fine tune. So this is generally we do also in the case of the PID controller tuning, the range of the parameter. Initially you step size will be more, finally the step size will be less. So that is the main idea, how I can control the exploration and exploitation, how I can control the momentum, how I can control the velocity. So omega greater than 1, velocity increases over time and the swarm diverges. So don't take omega greater than 1. For omega 0 to less than 1, the particle deaccelerate and converges depend on C1 and C2. So you have to make the capability of exploration and exploitation with a larger value for exploration and a smaller value for exploitation, that already I have explained to you. So this is a classical particle swarm optimization. Okay. So ultimately now I'll tell you how to optimize this parameter. So Maurice Clark, you will see his website. There is a beautiful website that is known as Particle Swarm Central, where you will find a lot of literature, a lot of analogy, which is maintained by my good friend Maurice Clark. Okay, so he has done initially he proposed a constriction factor based PSO. So what happens in the constriction factor based PSO? This X is a constriction factor which is multiplied with no omega VIK plus phi 1 into this plus phi 2 into this, and the value of X is 2 by 2 minus phi square root of phi square minus 4 pi. Some mathematical manipulation, they have seen that phi equal to phi 1 plus phi 2 and phi is less than 4, slow convergence, greater than 4, faster convergence. That's why the initial paper has taken phi 1 and phi 2 is 2.1, 2.1, the summation is 4.2, which is greater than 4. So this is the constriction based PSO. So now I will give some idea how to generate the new variant of PSO. So one thing I have told, if you will change omega, you will have a better exploitation and better exploration. So initial paper suggests the omega value as 0.9. So what exactly I want to tell to you here, this is my number of iteration. At the starting, I will take omega equal to omega max, which is 0.9. As the search progresses, that is iteration, increases, this is the iteration, increases, I will decrease this omega from omega max to omega mean, which may be 0.4. So I am changing omega between omega max to omega mean in a linear decrement fashion. So a simple mathematics is omega equal to omega max minus omega max minus omega mean into iteration by maximum iteration. For example, maximum iteration 1000, iteration 1. So 1 by 1000 is a very small number, multiplied by this is a small. So initially omega equal to omega max. They will decrease when iteration exactly reaches maximum iteration. This becomes 1. So this will be omega max minus omega max plus omega mean. This will be here. So this is a linear decrement of omega along with number of iteration. So the idea is same. So you see, these are nature inspired algorithm, and definitely if I want to travel from point A to point B, initially I am energetic, so my omega value, my step size should be large. So I am traveling from A to B and I am coming nearer to B, the traffic is empty, I am driving at 80 km/h, the gate is only 2 meter away, I can drive at 80 km away although the road is empty. So you have to make a deaccelerate there. So because that is the finer sum. So that is the main way. So, okay, this is one idea. You can decrease omega from a maximum value to a minimum value linearly in a decrement fashion. Will the paper ends here? Only one paper you can communicate. So some people are coming with some other idea, because you see the basic idea is omega should decreases maximum to minimum as search progresses. So what some other people do, they do omega like this. Okay, so they keep omega constant for certain iteration, then they decrease it. Then have same for certain iteration, then decrease it. Then have same for certain iteration, decrease it. Certain iteration, decrease it. Now the originality is same. You are decreasing it, but not decreasing it in a linear fashion, but in a staircase manner. They call it staircase PSO, a new algorithm. See, the philosophy is same. Then you may find some paper, they modulate with a sine waveform. So this whole this will be modulated with a sine waveform. So sine modulated PSO. Somebody modulated with a cosine waveform, cosine modulated PSO. Somebody modulated with a wavelet, wavelet modulated PSO. Then some people, what they do, they make a band, omega max and omega mean. There is a band, and you generate a random number chaotically in this band, but they decreases. This is a chaotic PSO. So ultimately, you decrease the value of omega from a large value to a small value as the search progresses. How will you decrease it? Depend on you, but the philosophy is this. Because you want exploration at the initial stage, exploitation at the maximum stage. So I hope you will get some idea. Now you come up with your new idea how to change omega. That may lead to a new algorithm, but not necessarily your new idea, new algorithm will give you the best result. Ultimately, you have to tune those parameters. So, okay. Coming to this, large in W, better global search, small w, greater local search. I am not going to the flow chart. I will tell you some variants of the PSO. If C1, C2, 0, you see C1, C2, 0, you don't have to take social interaction as well as your own self-confidence. Nothing can be done. So you will, your movement is unidirectional. C1 is greater than 0. C2 is not there. It is cognition only model, because self-cognition. The search progress based on your self-confidence. C1 0, C2 greater than 0. It is social only model. C1, C2 both are greater than 0. Then the particles are attracted towards the average of the present and the best. C2 greater than C1 is more beneficial for multimodal problem. C1 less than C2 more beneficial for multimodal problems. Low C1 and C2 smooth particle trajectory. High C1, C2 more acceleration and abrupt movement. So these are some observations on C1 and C2. But I will give you another idea how to change C1 and C2. This is a beautiful algorithm also published one of my collaborator, Salman K. Halgabuge, who is Dean at some Australian university at present, published in 2004. Okay, they are mechanical engineer. So what is C1? C1 is a self-learning. C1 is a cognitive learning factor. You learn from yourself. What is C2? It is a social learning. You learn from the global. So I give here always a classic example. I want at the end of class 12, I want to put my daughter or son to go for FITG or XYZ, whatever, maybe the coaching. I don't bother for engineering. So what I'll do, will I put him from the nursery or class 1? Definitely not. So that is the basic philosophy. When the particle is starting at the initial stage, the iteration is low, then give the thrust on self-learning. But as the iteration progresses, you give the thrust on social learning. So to achieve it, whatever happened in society or the psychology is, initial stage, iteration is low, C1 should be high. You can see this from example. C1 at starting 2.5 minus 2 t into maximum iteration. So this becomes 0. So initially C1 is 2.5. It decreases to 0.5. So 2.5 to 0.5. C1 decreases. And simultaneously, C2 increases from 2 to 2.5. So I'm linearly decreasing C1 and linearly increasing C2 because the main idea is at the initial, I don't want to give a thrust towards the social learning. Initially, the learning should be self. Try to learn, try to rectify your own mistake. Then as you go on, you have an interaction with your friends, you have interaction with your teacher, you have interaction with the neighbor, you have interaction with the global leader, then accordingly adjust your velocity. I can follow my leader. So that is the main idea. Don't try to do the reverse because this must follow certain principle which happens in biological inspired computing. Okay, so they decrease C1 and C2 in a linear manner. That's it, the end of the story. No further improvement. You can do it staircase, you can do it evaluate modulated, you can do it anything. But there is another beautiful algorithm which touched me upon and I want to share with you, that is known as this adaptive particle swarm optimization. Okay, and what they do, this one, sorry, an emotional particle swarm optimization. So you study the emotion of the particle and accordingly you decide the C1 and C2. So how will you study the emotion of the particle? I can study the emotion of my kid who is coming from the class and the day was the declaration of the result. Okay, so if he'll enter in the house with a smiling face and yeah, I do, I am the winner, then definitely I will know he has secured good mark. And if he comes, I don't know, I have to ask my wife when the kid has reached the home, then definitely there is something. So that is, the emotion is proportional to the evaluation. You evaluate all the particle in a particular iteration. So why should I will give to all the particle as per the earlier algorithm, all particle at the initial iteration C1 low, C2 high? No. At iteration 1, I am evaluating all the particle. Some are happy, some are sad. So I have to make a threshold. How to make a threshold? Very easy. The minimum, suppose it is a maximization problem. The maximum, the best particle evaluates 1000. The worst particle evaluates 200. So the average is 1000 plus 200 by 2, 600. So if the average is 600, any particle evaluating more than 600, I will assume they are happy. Any particle evaluating less than 600, they are sad. So what I will do, those particles who are happy or who are joy, I will give a more C2, less C1. Those particles who are sad, bhai aap akla chalo, let us have the confidence. C1 low, C2 high. So that is the way, rather than making a uniform C1 and uniform C2, I'll divide this C1 and C2 looking into the joyness of the particle, looking into the performance of the particle. Clear? So this is known as emotional based PSO. So you can change C1 and C2 in every iteration rather than for every particle having C1 high, C2 low. Now there is another point. If anybody has understand the fuzzy, now I am telling a particle evaluating 600, more than 600 is happy. So a particle evaluated 601 is happy. A particle evaluated 599 is sad. This is not fair. So I can tell the particle who is evaluating 601 is only 1% happy and 99% sad because somebody is there who has evaluated 1000. So likely here, instead of making these two particles to the two sets, which are the crisp set, where the belongingness is either 1 or 0, more than 600 belongingness is 1, less than 600 belongingness is 0. So you assign C2 and C1. I will not do that. I will make a fuzzy emotional PSO. Okay, what is this fuzzy emotional PSO? Yes, I will change the C2. Those who are happy, for them I will make C2 more, C1 less. But looking into the belongingness of a happy one. If some particle is evaluating 1000, for him or for that particle, whatever will be the C2, if some particle is evaluating 601 or 610, should not be the value of C2. So C2 will change for those particles based on the fuzzy membership function. So this is another idea. So I hope all of you, if you understand this basic algorithm, you will get some new idea to generate a new algorithm. Now, how to test all those algorithms in standard benchmark function and all other functions, I know few of my friends, Professor Swagatam Das and Professor Bansal, even my all the other colleagues who will give the talk, they will explain you. But here my only point is to understand or to tell you what are these algorithms and how will you tune this parameter of the algorithm. Okay, so let me stop here on this PSO. We'll meet later on for the session. And if any question, you are free to ask. Yeah. Yeah, Professor Nanda.
Sir, I am looking at the chart box.
I'm not able to listen you. I don't know why I'm not able to listen you. Will I join again?
No, sir. I believe. Can you able to listen me now?
Any other participant or anybody can tell something?
Sir, can you able to listen me?
Professor Nanda, I'm not able to listen. I don't know where is the problem. Whether the problem is mine or problem is yours. Or you can tell if they have any question, they can type in the chat window. I will answer that. Okay, there is a question.
Listen me.
There is a question: how many particles we should choose? 10, 100, and 1000. Okay. So the answer to the question is: you look into the dimension of the problem. You look into your search space. You see, suppose I have lost my coin in my room, and the room dimension is 5 meter. Is 3 meter to 4 meter. So I can't have 100 people inside that. So the number of particle, if you want to choose, then you have to choose looking into the dimension of the problem and the search space. Okay. Then the next is, which is the best algorithm for optimal location of EV charging station? You see, the location of the EV charging station is a binary problem. So you have to look into, if it is a binary problem, then in that binary problem, you have to look, mostly you can go for either to put it or don't put it. But simultaneously, if you want, you have to put a charging station or don't want to put a charging station, and what is the capacity of the charging station, then whether to put a charging station is binary, whether to have a distributed generation in an existing distribution network is a binary, but what is the amount is your real quantity. So you can go for any algorithm. Okay. How to treat equality constraint? Yeah, there are the constraints. The constraint handling may be discussed by somebody. In any evolutionary algorithm, the constraints are handled by the violation of the constraint. If you are violating some constraint, then you can handle it. So there are different constraint handling approaches, which I may tell in the coming class, or any other speaker can tell. Any other questions? Can you use this algorithm for process control problems? Yes, if your process control problem, are you want to find out the tuning the parameter of the PID controller, or you want to optimize the parameters of the system? Yes, but please remember, you have to define your objective function very clearly, what you want to achieve. How to map my real life optimization in objective function for PSO? I'm not sure about what you are asking. If you can put a mail, exactly what is the problem, what is the optimization problem, then I can tell you how to map. Because ultimately, you have to find out the number of variable. Once you are finding the number of variable, you can change. How do people hybrid the algorithm? Will you teach that also, sir? Okay, there are some hybrid algorithm. Maybe when I will discuss the multi-objective optimization, and you have already listened some other optimization problem, then I can tell how to hybridize. And definitely, when I want to hybridize, I have to look into the feasibility of the solution. Okay, I'll tell you definitely in the next class. Okay. Yeah, Professor Nanda, we'll finish here.
Sir, can you able to listen me? Am I audible, sir?
Anyway, thanks. I am not able to listen to you, but I have answered all the questions what have been typed. I'm thankful you have given me the opportunity. Maybe there is some problem, and you can carry on to the next class. And
Sir,
yeah.
you have the next
So,
class. Yeah.
Thank you. Thank you. I may leave now.
So thank you, sir. Participants, can you able to listen me?
Yes, sir. You are audible.
Okay.
Good evening, everyone. I would now introduce our next speaker and the organizer of our FDP. Dr. Satyasai Jagannath Nanda is a senior member of IEEE. He received the PhD degree from School of Electrical Sciences, IIT Bhubaneswar, on August 2013. Prior to it, he completed his MTech from Department of Electronics and Communication Engineering, NIT Rourkela. He received the BE degree in Electronics and Communication Engineering from ITER Bhubaneswar, affiliated to BPUT Odisha. He was the recipient of Canadian Research Fellowship GSEP from Department of Foreign Affairs and Intern Trade DFAIT, Government of Canada, for the year 2009 to 2010, with which he has worked at University of Western Ontario, Canada. He was awarded Best PhD Thesis Award at SOCPROS 2015 by IIT Roorkee. He received the Best Research Paper Awards at SOCPROS 2020 at IIT Indore, IC3 2018 at SMIT Sikkim, SOCPROS 2017 at IIT Bhubaneswar, IEEE UPCon 2016 at IIT BHU, and Springer OWT 2017 at MNIT. He is also the recipient of prestigious IEI Young Engineers Award in the field of electronics and telecommunication engineering for the year 2018-19. He has published 45 peer-reviewed journals, 42 conference proceedings, and 13 book chapters, which have received more than 1,300 citations. He has supervised 6 PhD, 24 MTech theses, and received travel and research grants from SERB, UGC, CCS, TDS, INSA, INAI. He is also in charge of digital signal and image processing lab here at MNIT Jaipur. With this brief introduction, I request Dr. Nanda to take over the session. So over to you.
Thank you, Akanksha. So, am I audible? Let me share the screen. I believe it is audible to participants. My audio and video are clear. You can able to see the slides.
Yes, sir.
And my audio and video are okay.
Yes, sir.
And when I am writing on this, is it working fine?
Yes, sir.
Okay. So last 2 sessions, there are expert talks on nature-inspired optimization algorithms and its potential application. My supervisor, Professor Ganapati Panda, sir, as well as Professor B.K. Panigrahi, sir, has very beautifully narrated about the nature-inspired optimization algorithms, as well as specifically the particle swarm optimization and its variants. Now, in this session, I am going to take you about the fundamentals of the classical optimization techniques and their applications. So, when we are saying about an optimization problem, what is a optimization from a mathematical point of view is defined as we have to either maximize a particular function or minimize a particular function is known as optimization. 2 things, either maximize or you have to minimize a particular thing. Okay, function fx. And this fx is known as an objective function, whereas x, the variable we are optimizing, that can be a single variable or that can be a vector of variables, like our director Professor N.P. Padhi was saying about vector of the things today. So it can be a single variable, it can be a lot number of variables. Okay, it can be a big data optimization problem as well. So x1, x2, x3, xn, how many number of variables you are going to optimize? So that much complex your optimization problem will have. Then there is a certain portion of the optimization problem is known as constraint optimization. So you have to minimize the function x. Okay, suppose sin x, one simple function, sin x we are minimizing or maximizing. Okay, such that there is limit on the x. There is a function gx should be less than or equal to 0. If it is less than equal to 0, greater than equal to 0, such type of conditions is there. Suppose we are trying to maximize sin x such that x should be less than equal to pi by 2. Then that is a constraint imposed on us that we have to minimize sin x, but within the range that x should be less than equal to pi by 2. Okay, so if it is less than equal to, then it is known as a inequality constraint. If it is greater than equal to, then it is a equality constraint. So like that, many real life problems of engineering, they require such type of constraints to be satisfied while doing the optimization task. Okay, so the optimization task is basically easily formulated as a linear programming problem. Okay, linear programming in some of the engineering basics we used to read, as well as in BSc mathematics also we used to teach linear programming. So what is linear programming? It is we are going to optimize a linear function. The function is assumed to be linear. It is not non-linear, it is a linear function like z is equal to c1x1 plus c2x2 plus cnxn. x1, x2, these are the variables up to xn. And c1, c2, cn, these are our constants. Okay. So with this particular function to be minimized, we have to take care that a lot of constraints should be also there. These constraints are simultaneously satisfied in such a way that there would be a non-negative restriction, that all variables should be greater than equal to 0. Means if there are n number of variables, then all the variables should be greater than equal to 0. Why all variables are positive? Because in many of the engineering problems, the variables are taken as positive numbers, because these variables like a production system. You are manufacturing number of cars. You cannot manufacture number of cars in negative numbers. -5 number of cars a company cannot able to manufacture. It has to always be either 0 or greater than 0. The amount of electricity supply to particular household, okay, in units, that unit cannot be negative. That has to be either 0 or positive. So many real life problems are always required optimization which are positive in nature. The values will come out in positive. So such type of problems can easily be dealt as a linear programming problems. Okay, so xj is greater than 0. That constraint is imposed on such type of problem. So suppose giving you an example, in many times the optimization problems are not directly defined to you, that maximize this particular function or minimize this particular function, that will not be given. A set of real life statements are there. from these statements, you have to formulate it as an optimization problem and try to solve it. Suppose, giving you an example, suppose a company manufactures two types of electric vehicles. Suppose you say A and B. The first type of vehicles, to manufacture this type of vehicles, you require two type of process. One is known as manufacturing and another one is known as finishing. So each vehicle, it has to be either manufactured and then finishing should be given. So in order to manufacture vehicle A, it requires 2 hours of manufacturing task and 1 hour of finishing task. And in order to manufacture vehicle B, it requires 1 hour of manufacturing task and 2 hour of finishing task. And now we have the constraint comes into account. The manufacturing unit, which is a practical unit or a practical plant, that runs only for 104 hours per month. As it is a machinery thing, you cannot able to run it more than this. Otherwise, your machines will be affected. So the manufacturing unit runs for 104 hours per month. And the finishing unit that runs for 76 hours per month. The profit you are going to get when you are selling type A vehicle is 6 lakh. And one vehicle, when you are selling it type B, it gives you 11 lakh profit. Why? Because with vehicle B, there is 2 hours of finishing. It looks more good because it is its finishing is better. Okay, so people purchase it with more amount of money. So profit is more, 11 lakh. So how many such type electric vehicles the company should manufacture to obtain the best return? This is our problem. So now we will formulate it as an optimization problem. Suppose we are saying that the company manufacture X1 number of vehicles of type A and X2 number of vehicles of type B. Okay. So X1 number of vehicles of type A. So in type A, we have 6 lakh profit. So X1 number of times, so 6X1 is the total profit. Type B, 11 lakh profit. So X2 number of vehicles, so total 11X2 is the profit. So total profit is 6X1 plus 11X2. That much amount of profit the company should obtain. But now we have come into the restriction that the manufacturing unit has to run only 104 hours. So in how much amount of time is required for manufacturing? For manufacturing, you see the manufacturing vehicle A requires 2 hours of manufacturing, while vehicle B requires 1 hour of manufacturing. So 2x1 plus x2. 2x1 plus x2 is less than equal to 104. Similarly, the finishing unit has 76 hours. Finishing unit, how much time it occurs? 1 hour of finishing vehicle A and 2 hours of finishing vehicle B. So we have x1 plus x2 is less than equal to 76. So now the entire problem can be defined as you have to maximize this Z profit is equal to 6x1 plus 11x2 subject to constraint 2x1 plus x2 should be less than equal to 104, x1 plus 2x should be less than equal to 76, and you know these are the number of vehicles we are manufacturing. So x1 has to be greater than equal to 0 and x2 has to be greater than equal to 0 because you cannot manufacture negative number of vehicles. Okay. So now we have, from the statements, we have formulated the problem. Then how to solve this problem? So this one of the simple way to solve this particular problem is known as graphical method. So let's draw graphs to solve this particular problem. Okay. So here we have subject constraints 2x1 plus x2 is less than equal to 104 and x1 plus 2x2 is less than equal to 76. So these constraint, we will make it equalities. That is, x1 plus x2 is 104 and x1 plus 2x2 is equal to 76. Okay. Now you substitute x1 is equal to 0, find out x2, x2 is equal to 0 and find out x1. Okay, that is x-intercept and y-intercept. Draw this particular line. Okay. So here two lines are drawn. One is x1 plus 2x2 is equal to 76. Another line is 2x1 plus x2 is equal to 104. Okay. By substituting the x1 is equal to 0 and x2 is equal to 0, two lines are drawn. These two lines intercept each other at point C, that is 4 and 16. Okay. Now, what is the common area between these two lines? This particular lines I have drawn in yellow, this blue colors, they are the points. That is the region of intersection between these two lines. Okay. Or common area between these two lines. Okay. So now the points which are at the boundary points of this particular area, they are the probable solutions or the feasible solutions or most probable solutions. Okay. So what are the points? One is on the y-axis, that is 0 and 38 point A. Another one is point B on the x-axis, 2 and 0. And another point is C, which is the cross section between these two lines, that is 4 and 16. These are all feasible solutions. So among these three feasible solutions, which is the perfect solution? That is, you can find it out by substituting these 3 points on the function. Okay. So our function to maximize is z is equal to 6x1 plus 11x2. So now substitute these x1 and x2 values. You will find that at the C point, you are getting the maximum value 440. Okay, therefore C is the optimal point. Now, like we have solved a maximization problem, same way you can formulate a minimization problem to solve. For example, suppose minimize z is equal to 20x1 plus 10x2, such that x1 plus x2 is less than equal to 40, 3x1 plus x2 is greater than equal to 30, 4x1 plus 3x2 is greater than equal to 60. And x1, x2 is greater than 0, obviously, because we are solving linear programming problem. So this is a minimization problem. So how to solve it? Now these three inequality constraints, we are making them equalities. So now we have three lines. X1 plus 2x2 is equal to 40, 3x1 plus x2 is equal to 30, and 4x1 plus 3x2 is equal to 60. Now find out all the intercepts in x and y axis and draw these three lines. So you can observe I have drawn three lines. One is this, another one is this, and another one is this. Now what is the common area between them? So that is highlighted over here by these blue lines. Okay. Now what are the boundary points? The boundary points are this point A is equal to 4 and 18, B is equal to 6 and 12, C is equal to 15 and 0, D is equal to 40 and 0. So these are the common points. Okay. How I have found out B point? By solving these equations together. Okay, I have found the point B is equal to 6 and 12. Now, in this particular area, these four are the feasible solutions that is possible. Now, what is the exact solutions or optimized solution? By substituting all these 4 points, you can find out which one is the minimum. The B point that has come out to be minimum 240, that is the minimum value. Other 3 points are giving us the max, more than higher values. Okay, so among the probable solution, this is the exact optimal solution. Now, the third case I want to discuss these two cases, one maximization problem and one minimization problem. we have exact solutions. Now I am going to discuss another case, which is a unbounded solution case. In mathematics, sometimes the solutions become unbounded. Okay, so what is the meaning of that? Just have a look. An example is maximize z is equal to 4x1 plus 5x2 such that x1 plus x2 is greater than equal to 1. Minus 2x1 plus x2 is less than equal to 1. 4x1 minus 2x2 is less than equal to 1, and x1, x2 should be greater than equal to 0. Now this particular example we have to solve by the graphical method. So now these three equations, we will inequalities, we will make them equalities. Okay, and then try to draw the lines. So now the x-intercept and y-intercept we have substituted, and then find out the lines equation. So just have a look at the three lines equation. One is this particular one, another one is this particular one, and this is the third one. Okay. So if you find out the feasible region, these two lines are going parallelly. One is moving like this and another one is moving like this in parallel manner. There is no convergence of this particular area. Okay, no bounded values. So they are moving parallel to infinite directions. So the solutions are unbounded in nature. Okay, many of the times you will get such type of unbounded problems as well, real life problems. Okay, so these are unbounded solutions. Now then, another particular example I want to discuss with you, that sometimes it says about a no solution case. No solutions also do exist. That means, for example, suppose maximize z is equal to 3x1 plus 4x2 such that x1 minus x2 is less than equal to 1, minus x1 plus x2 is less than equal to 0, and x1, x2 is greater than equal to 0. So these three are the, this is the condition. So there are two equations. So these two equations, when we try to plot, one particular area comes out with this particular blue lines, and another particular one is this right side. I am drawing the red color lines. So you can observe that there is no common area which is defining between the blue lines and these red lines. So there is no bounded, no solution in this particular case, no common area between these two solutions. So there is no feasible solution exist for this particular problem. So you can define it as a no solution case. So now moving on to further solving the linear programming problems, there is a concept known as symmetric dual problems. What do you mean by symmetric dual problems and what is its importance? Suppose we are trying to find out that z is equal to c1x1 plus c2x2 plus cnxn. This particular problem I want to find out the maximization, okay, by satisfying these particular constraints. Okay, so this particular problem mathematically is a maximization problem. So this maximization problem can also be solved as a minimization problem by considering it as a dual problem. Why do we need a dual, or why a maximization problem we want to convert it to a minimization problem? Because sometimes these variables, look, a11, a1, a1n, these constants, they are associated with the equations. They are very typical in nature. In engineering optimization problem, stress, strain optimization of a building, or sometimes in wireless sensor network, the bounded values. So for such real life problems, these a11, a12, these values are very, very small, like 0.00005, 4 zeros and then 5, very small value, or it will be a very large value like 1.006 into 10 to the power 9. So like these variable values will become very small, whereas this b1, b2, bm, these values, they are constants, maybe like 2, 3, 4, 5 small the things. So if we will transpose it to a dual problem, then we can easily solve this particular problem. Maximization problem can easily solved as a minimization problem, or minimization problem can be easily solved as a maximization problem. So the variables which will be easier for us, that one we will try to solve with the equations. Okay, so the dual of this problem is defined like this: z dual is equal to b1 w1 plus b2 w2 plus b2 wm. So you observe this b1 to bm that has come over here. Okay, now this particular one, a11, a1, a1n, so this, and am1, am2, amn, so this particular horizontal line that has come over here as a vertical line. So you observe as a vertical line. So this horizontal line has come as a vertical line over here. That means the matrix is transposed. So the second line over here that has come over here. Okay. So that is the matrix has transposed. So to determine a dual of the problem, you have to do the coefficient transpose the coefficient matrix. Okay. Then you have to interchange the role of the constant terms and the coefficient of the objective function, and then reverting the inequalities. Okay, that means if it is a simply saying you, if it is a greater than problem over here, then you have to make it as a less than problem over here. Okay, if it is in the original version, it is greater than, it will be less than. Okay, and then if it is a maximization problem in the original, then you have to make it as a minimization problem. Okay, now over here x1, x2, xn is greater than 0. Here w1, w2, wm is greater than equal to 0. So this is how you are going to formulate a dual of the problem. So for example, giving you, suppose you have to write a problem, minimize z is equal to 3x1 plus x2, such that we have this particular thing: 2x1 plus 3x2 is greater than 2, x1 plus x2 is greater than 1, and x1, x2 is greater than 0. So this is a maximization, this is a minimization problem, and I want to find out the dual of the problem. So the dual will be minimize the thing. Okay, so now over here, you see 2, 3, and then 1, 1 over here. 2, 3, 1, 1 into x1, x2 is greater than equal to 2 and 1. Okay, and this particular thing is written like 3, 1 into x1, x2 is equal to cx. So this we have to minimize, and the dual of the problem is now change the transpose this matrix, that is 2 and 1. Okay, they have come out 2 and 1 multiplied with w1, w2, that is w1 plus w1 plus w2. We have to maximize that one, and now this we are transposing 3, 1, 1, that is transposed 3, 1, 1 has become column, and then multiplication is less than equal to 3, 1. That is how we have formulated the dual of the problem. Now, besides the linear programming, I hope you have got an idea about the linear programming based optimization. We have derivative based optimization. Okay, from our +2 mathematics, we have been doing this particular one. That is, from the beginning of the curve at a particular step size, you go on taking the derivative. The derivative represents the slope of the curve. Okay, and whenever you are going on changing the derivative, wherever there is a change in slope, you either from positive to negative or from negative to positive, then there you declare it as a maxima. So what is the step size you are going to take on this particular curve, that you can able to fix it by various methods. So based upon this particular derivative based methods, there are many numerical methods have been reported. Some of the prominent methods are steepest descent method, Gauss conjugate gradient method, Gauss-Newton method, Leavenworth-Moderated method, and many more numerical methods have been developed based on this step size based optimization. You go on taking the derivative until and unless derivative change the. So some of the very important application of these classical optimization techniques on adaptive filter design, I am going to tell you just a simple example of these application of these classical optimization technique. One is so one of the thing is a FIR filter design. Those who are from electrical and electronics backgrounds, they understand that the objective of the filter is to block certain amount of signal and transmit a good quality signals. Okay. So this is a particular device. Filter is a device that removes unwanted noises. And now in these days, everywhere there is digital communication. So we normally do digital filtering methods. Okay. So digital filtering methods. So the objective is to design an digital filter that will remove all the noises and that gives us a smooth signal. Okay, so for this one, we have chosen the finite impulse response based filter. Okay, and this one you can design using the Z transform. Okay, so in time domain, this particular filter is defined like this. Output of the filter Yk is summation of the weighted sum of the inputs, previous inputs, x1, x2, xk, xk minus 1, xk minus 2, these are the inputs. This is the present input, xk is the present input, and z minus 1 is 1 unit delay. That means it's previous input. Now this is present input to a system and this is previous input to a system. Previous input we are also storing. So 1 unit delay, 2 unit delay, and like L unit delay is there as the input. Now present input and its delayed version of the input, they are applied to the input of the filter, and all these things are multiplied with certain weights. Okay, these are the parameters W0, W1, W2, and WL. They are responsible to reject the particular noise and pass on the particular effective signal and gives you your desired output Yk. So Yk is summation of W0 into Xk plus W1 into Xk minus 1 plus W2 into Xk minus 2, like that, summation of 1 to L. So here L is equal to 0 to capital L, WL X minus L. This is in time domain. When you take it in Z domain, Wz is equal to summation n is equal to 0 to n, Wn z minus n. So this is the transfer function, and Yk is the output of the signal. Now this W0 to WL, this is fixed for a fixed type of system. When you design an adaptive or an intelligent filter, that is, that can able to take the decision by itself. Suppose now it is the weather condition of Rajasthan that fluctuates very much. In the summer, it is 45 degrees centigrade, and in the winter, it goes up to 1 or 2 degrees centigrade. So your devices you are using that should have the capability to adjust itself to such type of temperature variation, that is from 0 degree to 45 degree centigrade. Okay, so for this type of climatic situation, if you make a very fixed system, then its performance will degrade. The system has to change its parameter adaptively to the heating conditions as well as to the cold environments. So this W0, W1, W2, and WL, these values has to change with respect to the time. So how to change these values? So This is an example of this particular system, practical system. So this is a fixed system. You see W Z is equal to 0.6, 0.93 Z minus 1, 0.63 Z minus 2, 0.93 Z minus 3, 0.26 Z minus 4. So the original input, it's multiplied with this fixed weight. So these weights values are given already. Okay. So this YK is depends upon present input as well as its delayed version of the input, and the third delay as well as second and first delay portions. Okay. Now I am making these particular weights not fixed, but they will change with respect to time, change with respect to temperature, change with respect to pressure, change with respect to environmental change. Then how can I able to adopt it? So that aim is to design an adaptive system. Parameters are alterable, adjustable with change in environment. Or you have to design an adaptive system which can self-optimize itself with respect to the time. Self-optimize itself. You should understand. Self-optimize. It is automatically changing, automatically optimizing its characteristics in accordance to the environmental changes, and it can able to deal with the new situation and able to repair itself. Such type of systems we are trying to design. So over here, to design that particular thing, you need a targeted signal. Okay, what is your desired signal, or what is, whether it is a temperature is going high, temperature is going low, that one you should give as a feed to the input of the filter, as a target to the filter. Okay, so the difference between this output of the filter and this targeted signal leads to the error. This is the error signal. Okay. That means your filter is giving a certain amount of output, and now the temperature changes of the environment, and that will give as a feed to the filter that now temperature is going high from 30 degree to 40 degree to 45 degree. Okay, it is going high, that feed. So with that particular feed, the filter output will be subtracted, and that leads to this error EK. Now we have to use an adaptive or the optimization algorithm to find this weight of the filter, or make these weights changes, W1, W2, WLK, all these weights values we will change in such a way, or optimize in such a way that the filter gives us the perfect desired output. So for that one, we are going to optimize based upon this error. Our objective is to minimize this particular error with respect to time. So how we can able to do it? That this error is nothing but the difference between this desired signal and the filtered output signal. Okay, so now the error is maybe a positive entity or maybe a negative entity. Okay, so when you are minimizing the error or quantifying the error, that can be a signal which is varying positive, negative like that. So you cannot able to quantify it perfectly. So what we will do, error square we will try to minimize, which is always a positive function, and you will have a entity which will be clearly visible that initially the error square is this much higher amount, and with respect to progression iteration, its value has got minimized. Okay, so the error square is taken as the performance function for minimization. Okay, so error square, you can able to easily calculate. This particular one is the desired signal and the filtered output signal. The filter output is nothing but the weight into the input of this signal. So when we are taking the square of this particular thing, so a minus b whole square, this particular is one is taken a minus b whole square, that is a square, and then multiplication of these two things, and then minus 2ab. So that is given over here. And then we are not defining it for only one sample, but there are large number of input samples we are passing through the filter, and the filter should give us perfect output. So when we are taking it about large number of samples, then we normally take the expected value of the samples or the mean value of the signals. So this is expected value we have taken on the both sides, and then calculate the minimize this particular expected value of error square, or minimize this error square. So when we are minimizing this particular function, so it has come out that this is expectation of dk square w transpose x into x transpose w, and into expected value of this desired and expected value and the weighted value. So this gives you that the input signal is multiplied with itself. So that gives us the autocorrelation function. That is the function autocorrelation matrix comes into account. So this is a function like this: x0 square, x0 x1, x0 xlk. Like that, this is the autocorrelation function, and this is the cross correlation function. So we are trying to optimize the thing, and we are getting the thing in the form of autocorrelation of the signal and the cross correlation of the signal. That means how much the input signal is correlated to itself and how much it is correlated with the desired signal. Okay, so this is the error signal error square function we are trying to optimize. So when we are trying to optimize a function, then what we will do? We will take the derivative, make it equal to 0, and then try to find it out. Like always the derivative based optimization. So this is our function over here. Sigma is equal to error square. So this we are trying to minimize. So when we are plotting this particular error square function with two weights, W1 and W2. You know the W1 and W2 over here we have taken. You can observe that here are the weights. Okay. And W0, W1, W2, like that. So two weights we are considering on this particular platform. You observe W1 is one weight and W2 is another weight. And this is the mean square error function. In third dimension, when we have plotted it, you see it is a bowl shape plot, and its minimum value, minimization value is over here 50-50 at this point. This is the minimum value. So this is an optimization problem, and in this particular problem, this is the point, or this is the minima. Okay. So over here, this is the two-dimensional contour plot of that particular plot, that at 50-50, we are going to obtain the minimum value at this particular point for this particular error performance surface. So now take the derivative of that particular error square. So when you take the derivative, you are going to get 2RW minus 2P. So this you have to make it equal to 0 and find out this particular weight. What is the value of this weight? Okay. Now when we take the gradient or the derivative, if you plot the derivative, you will observe that these derivatives are always pointing outwards. So you have to move in the opposite direction, that is the inward direction, to get the optimal. So this is equal to 0, 2RW minus 2P is equal to 0, and W is equal to R inverse P. R is autocorrelation matrix and P is cross correlation matrix. So your optimal weight value is equal to R inverse P. R is autocorrelation of the input signal with itself, and P is the cross correlation of the signal. So this particular optimal weight vector is known as winner weight vector, and this equation is known as Wiener-Hop equation. Okay. So if you know the Wiener-Hop equation, you can easily find out the optimal weight of the filter, and you can easily also find out the optimal weight of the neural networks. You are using linear neural networks, you can easily able to find out the optimal weight without the training with this autocorrelation and cross correlation function. So this is primarily important, but all the times when we do not have large number of samples available, we cannot able to take the derivative based approach. At that time, we have to take it iteratively. That means if it is an online process, we do not have all the samples of these things available. At that time, we cannot able to apply this particular approach or gradient based approach. So at that time, you have to do the weight update with the least mean square algorithm. This is another interesting derivative based approach in which you are taking the instantaneous error into account, not the error of all the 1000 samples, but how many samples are available to you. Suppose first instant 1, second instant 2, third instant. At the time you are getting the inputs, you immediately take them and then update the weight. So that makes out an interesting weight update algorithm, that is wk plus 1 is equal to previous weight plus 2 mu error into input. Mu is the learning rate or the step size with which you are going to update. So this is the famous equation for online. If you are doing for offline processing, that means all 1000 samples are available. You go ahead with Wiener-Hopf equation and directly find out the weight of the filter. If you are have instantaneous thing and you are making an online weight update, then apply this particular least mean square algorithm, which is helpful. So ultimately, this least mean square algorithm also converges to the Wiener-Hopf solution when you are taking larger number of samples into account. So this one effectively applies to system identification problem. That is when you are applying the input to a unknown system and the unknown system do have the noise associated with it. Okay, so your objective is to develop a model, develop an adaptive model by minimizing this error in such a way that with this particular optimization algorithm, it will fine tune the weight of the model, and the weight of the model represents the weight of the system. Then your training will be done. Okay, and you can identify or estimate accurately the parameters of an unknown system, and the noise will be eradicated with respect to the time. So this is a practical model of this particular system. That is, the upper part is the system transfer function. A very simple example, hz is equal to 0.5 plus 0.3z minus 1. Okay, a simple filter. And the output, this is the input signal given to the filter. And the filter has two weights. One is 0.5 and another one is minus 0.3. And here is the noise component is added, as it is a practical system. So yk is the output of the system, and in the lower part we are applying the same input to the model, and the model weight is trained by this least mean square algorithm for minimizing this particular error. So you can observe that for three different mu values, this is given. So 30 dB noise is added for this particular thing. The green color line is the optimal value. And with three different learning rate, the results are shown to you. 0.25, 0.05, and 0.01. You can observe that when I have taken larger step size, okay, larger step size, at the time it is converging very fast, this blue color thing, but it is not reaching to this particular green solution. When I am taking very medium values, mu is equal to 0.5, at that time it is converging slowly. And if I am taking very lower by mu value, at that time it is reaching to my green color solution. Okay, but the difference is the blue one is converging very less amount of thing, like 50 number of samples. The red one is taking 100 number of samples. Yellow one is taking 400 number of samples. Okay, so you want an accurate solution or you want a quick solution? That depends upon you. If you are spending, you have more time, you want a accurate solution, then move ahead with lower step size. Lower step size, slowly you can move to the optimal. Okay, but with larger step size like mu is equal to 0.25, you are rapidly moving to the optimal. But you will rattle around the optimal solutions. You cannot able to converge it. Okay, so this is a minimum bowl shape type of thing. In the bowl shape, you are moving here, there, actually, rather than converging to the particular solution. But if you are taking smaller size, there is higher probability that you will get exactly converged to the optimal solution, like this particular yellow curve over here, compared to this blue color line. So that is what about the step size, variation in step size performance on the convergence of the thing. So 3 different type of convergence curves I have shown you over here over the progress of iteration. This is the convergence curves of the parameters. You can see that this is there is so much deviation in this particular thing when you have taken mu is equal to 0.25. When mu is equal to 0.05 is taken, there is less deviation over here, and mu is equal to 0.01, very less deviation over here. The parameters are exactly getting converged. Okay, so with these parameters values, you can observe that the MMSE value is getting very close. We have taken 30 dB as the parameter setting, and here we are getting minus 29.99, which is pretty close to 30 dB. And the estimated parameters are pretty close compared to that of the higher mu values. Okay. But for taking higher taking lower mu values, you have to compromise with the time you are spending to obtain the solution. You need to wait for 500 number of samples to get the solution. If you are taking larger mu values, you are getting quick solutions. Okay, so that is what application of the benchmark derivative based algorithms for the adaptive system identification or adaptive filter design. So we have learned about the Wiener-Hopf equation and the LMS algorithm, as well as the linear programming based approach in this particular session. So that much from my side in this session. So if we have any query. Are there any query from any participants?
So there's no query yet.
Okay, so participants can always write their query to me on my mail ID over here. So we have, I am constantly sending the materials and the things. So my schnanda.ec@mnit.ac.in. So with that one, they can able to send the queries if they have any. So I stop my session over here, and we will take a gap of So one of the query is how to obtain dual in nonlinear problem. So nonlinear problem, we normally do not go for the dual based analysis. So nonlinear solutions, we make it quasi-linear and then go for the dual based solution. Or we can formulate it as a quasi-linear problem or summation of the linear problems. A nonlinear problem can be broken into a portion of linear things, and each of the linear part can go ahead with the dual based approach. So now we will take a break for 2-3 minutes, and then our next session will be addressed. So practical example application of the optimization technique I have discussed now with the adaptive filters design, adaptive parameter estimation or system identification type of problem. Any unknown system parameter you can able to estimate, like suppose there is a blast furnace is there, you cannot able to record its temperature by going near to it, so you have to place some sensor, and for those sensor the parameter estimation is very important. So for those kind of approaches, your system identification plays a very important role. Okay, so like that you can make it for many practical problems. Okay, so the next session for this will be taken by Prashant Jain sir. Sir, are you there? So he will be joining soon. So please wait on this link. We will be joining soon after 2-3 minutes. Hello. 7:45.
आ रहा है क्या सर? नहीं आ रहा।
Good evening, Dr. Nanda.
Good evening, sir.
सर इन केस अगर बीच में मेरा थोड़ा नेटवर्क ब्रेक हो तो कोई प्रॉब्लम नहीं है, थोड़ा सा मैं रूरल एरिया में हूँ आज, तो कभी कभी
Okay,
बीच में हो सकता
sir.
है, मोबाइल डेटा से काम कर रहे हैं,
Sir,
बट आई होप कि देयर वोंट बी एनी प्रॉब्लम.
sir. Participants, it is my pleasure to introduce Professor Prashant K. Jain, sir, from Department of Mechanical Engineering, IIIT DM, Jabalpur. Sir is professor in Mechanical Engineering discipline in PDPM, Indian Institute of Information Technology, Design and Manufacturing, Jabalpur, Madhya Pradesh. He obtained his degree from Indian Institute of Technology, Delhi, in the area of additive manufacturing process. He has published and presented several research articles on part quality improvement in the SLS and FDM process in leading international journals and peer-reviewed international conferences. He is currently dealing with sponsored research projects as AI of development of additional software integrated RP systems for improved part quality, supported by Department of Science and Technology, Government of India. He is also actively involved as co-PIs into ongoing research projects in the area of incremental street farming, sponsored by BARC, Mumbai, and Imprint India. Earlier, he has served as project scientist and project associate at IIT Delhi. His research interest includes additive manufacturing, rapid prototyping, tooling, CNC machining, geometric modeling, CAD/CAM integration, computational geometry, human power energy devices, and nanotechnology in manufacturing. So, with this brief introduction, I welcome you, Professor Prashant K. Jain, sir. Over to you, sir.
Thank you, Dr. Nanda. Kindly allow me to share my screen and
Yes,
participate. Since it's a lab session, so I will briefly introduce you the MATLAB through the PowerPoint presentation and quickly come to the directly on the screen so that you can have a feel of the software. And I would request whatever the question you have in your mind, please feel free to ask or keep on writing in the chat box. So without breaking the momentum, we will continue.
So Prashant sir, I have made you the presenter.
Okay, thank you. Thank you. So
now you can able to share your screen.
Yeah. I hope now it's visible, the in presentation mode. So dear participants, I hope my screen is visible to you now. Yeah, Dr. Nanda, my screen is visible in presentation mode. Yes, perfectly fine. I think now it is visible. So one thing before we go into this, the program on optimization techniques and introduce the MATLAB. I hope we all are aware we have utilized the programming maybe in one of our course or during maybe in our during the PhD program. Then we might have used starting like C, C++, or C# or the Java, then the Visual Basic, and then Python, then Scilab, and then MATLAB. Today's session we are going to introduce you the MATLAB programming, right? And why it is so important. I like the very much the quote from the Bill Gates. That the learning to write the program stretches your mind and help you think better, creates a way of thinking about things that I think is helpful in all domains, right? So this is the way when we write the program, we can have the generic type of solutions to our problem. We need not to perform the repetitive task every time the same thing we have to, otherwise we have to follow, right? So let us coming to the MATLAB part in today's session. I will briefly introduce you the 2D and 3D plotting with a style option, labels, titles, legend, various text options, axis, overlay, and then modifying the plot, specialized 2D plots, then the subplot and 3D plot with various use commands, right? So those who are new are those who know about the MATLAB, nothing to worry. In 10 minutes, we will come to the MATLAB screen online. So look at this. If we have this kind of plot, random number generation, the 50, and you can see on this screen, this is the plot you are running, right? So the x-axis is automatically defined by the MATLAB. See another case when you have the x-axis and y-axis both, and then we are plotting this. So we are plotting x-axis and then plotting values for the y-axis, and you see it. The important thing which I want to share here, you see here, what we have created, the x-axis, the y-axis 1, y-axis 2, and y-axis 3. Three values for the, right? So in this case, you see. Now my question is this, can you see this? There are three different colors. And in this command, we have not given any color, right? This is simply plot x-axis, y-axis, right? So how this color changes off, right? So that's MATLAB takes care automatically. If you do not provide any color for printing, it will automatically keep on changing the color for next value, provided this is in the single command, right? That plot is the single command, and within this plot, you are giving all these values, right? Now look at this. If we provide the style, the same graph, the same figure, you see here the plot, x value, y value, and here the line type we have given, right? Similarly, x, y, and then again the line type we have given. Similarly, x, y, and then again the line type we have given. So you see here, we have not touched the color, but the line type has automatically changed. Now you see on the bottom side, this plot, x, y, the line style, the three values we can take: the line style, the marker, and the color, right? So see here, various options are available to us to have the line, right? So you see here the blue color, the green color, the red, cyan, magenta, yellow, and the black and white. And similarly for the point style, the point, the circle, the X mark, the plus, the star, the S square, the diamond, the triangle, up, down, triangle, left, right, and then pentagram, hexagram, like this. Similarly, the line type, the solid line, the dotted line, the dash dot line, the dash dot, the none, no line, right? So this all these things we can do. We can also change the plotting functions by using, you see here, this is the plot. So this xy is the value. Now see here, this third value is defining the line type. So it is defining the line type, then color and the style, right? Then we can set other parameters like line width 2, right? These three dots are the asterisk marks, right? These marks are just to continue this command to the next line. Okay. So this the marker age color, marker face color, and marker size is the 10, right? So you see here the marker face color we have given here the G. G stands for green. The marker age color is K. K stands for black color. So you can see over here, right? This, right? You can see over in this marker, the age color is black. The inside filling is green, right? And the line type, line width, we have taken the 2, okay? And this line type, we have taken the dash dot connecting line, right? This one with red color, and the marker is the square marker. Okay, so that is how we have taken the marker. Okay, now look at this. Another thing, whenever we have this data from any value, we need to optimize it, and after optimization, we need to plot. We can directly copy this figure to the Word file with good quality, right? So see here the same data or multiple data has to be taken into the same graph. Then what we will do, we will put the hold on. So what will happen? This data, blue color and this green color, both data are coming into the same plot because we have put the hold on. So we have the plot and we can have another plot. If you do not put this hold on, what is going to happen? This data will be overwritten, right? This data will be deleted and this new data will only come into picture, right? So let me show you at least this option, right? Let me show you taking to the MATLAB. And in the meantime, I would request participant to please keep on responding, because otherwise I feel that whether I am connected still or not. So before I run some more programs, let me have a new file. Can you see the MATLAB screen on my computer system? So let me have a new file. So this untitled, and I am pasting this data, right? And look at this by this hold on line number 4. If I press Control R, sorry, this is now commented. So that means this line will not be executed. And if I run this program, now look at this. Yeah, it's asking me to save. Okay, let me save and then let me overwrite also. See here. See, the only one data has come, right? And if you see, if I switch on this hold on, right? And if I run this program, see here. Right? So because I am giving this hold all for all the figures, right? So that's why it is asking. Okay. So you see here now both the data are here in this figure. This the green color line you can see here. If you want, I will zoom it. See here, both the data are here. The blue color, the previous one, and the green color, both the data are available in your figure, right? So if you are going to use the plot command again, then it will overwritten the previous value. Then let me go back to the PPT and then see something more. Okay. Now look at this. This is for the subplot. You can see here on the top we have one figure, another we have this this figure, right? So what is happening here? This is the data plotted in the same figure window. This is another data with the same figure window. Or like this, you can have the two figure window. So suppose you want to have some data for Nyquist plot. Okay, so that the for two different values you can have the Nyquist plot or Bode plot in a different sub window and in the same figure. So see here what I have done here. X-axis, y1, y2, y3. Three values for this first figure, right? Then I have taken this subplot. So subplot, I have taken two rows, one column, and from this, the first one I have taken. Okay. Then we have this plot. So these values will go to this subplot, right? And for the second subplot, you see, already we have divided into subplot. So you can see here this subplot. Two column, one row, and this is going to the second position. So this is the second position, right? This is the second position, second graph, and that was the first position, first graph, right? So this is how we can transfer the data into the different subplots. Okay. Now we can. Right now we are in online mode, and I don't know whether you have the access to MATLAB or not. Otherwise, I would have been asked you to do this exercise. But anyway, no problem. Let us move. See, now coming to the 3D plot. You can see here the helix plot. Right? Okay, let me open the chat window in the side so I can keep on watching the comments. Okay. Yeah, please keep on responding. That will help me to understand. Yeah, I want to plot two figures in the first row and one big figure. Yes, this is also possible. You can change this subplot setting. We can do it. PTSJ, right? We can do it, right? And you see in this plotting case further. Yeah, Preeti, let me come move forward right now, okay, so that other participant will have an introduction. I will request Dr. Nanda to later on share with dedicated course details of MATLAB programming, starting from 22nd August after this course. So you can register to that program, and that will be in a very detail in the MATLAB only, dedicated to MATLAB. And then please keep on typing your questions here, okay? So whatever is there, we will include in the next course, and we'll try to answer whenever I move to MATLAB screen. I will try to answer. Okay. Now look at this. Here is the mesh grid. So this is the helix you have plotted. Now see here, when we go for the mesh grid, we have the XY. This mesh grid command will create a grid, right? The grid means like that you need not to give the values for everything, right? So sorry, this would be like this. Okay, 1, 2, 3, 4, right? 5 lines. Now this would be a grid. You can see, right? So this mesh grid command will create a grid like this. Okay. Now here you can see here, this is one value for X, right? This is x-axis, 5 values. So if you can say 1, 2, 3, 4, 5 for x-axis, similarly for y value 1, 2, 3, 4, 5, right? And here what you have given, you have started from minus 0.2, and suppose this instead of 0.1, I will take it this value as a 1. So it will start from minus 0.2, minus 1, 0, plus 1, and 2. That would be the grid in this case, right? So because once you do it programming, instead of increment 1, you can anytime quickly change this increment to 0.1, right? And similarly for y-axis, right? Now you will get two variables, x and y, so that you can plot the third variable in the z-axis direction. That's the right now I'm not going into much detail of these dot product and how to solve this equation, right? But for your understanding, let me run this program. Okay, let me come back. Let me show you this program. Okay, right, that's the program we have, and since we have 0.1 we have talked about, so let me make it 1, right? And now let us run. So you can see here, because we have taken it as a 1, so you can see here the increment is like 1. Can you see over here? You see here, let me put into the XY mode. You can see here the blue color line, green line, the red color line, and you see -2, -1, 0, 1, and 2. And similarly on this side as well, -2, 1, 0, like this, right? And now let me change this increment. So let me put 0.1, right? 0.1. So you can see, let me run this with 1 increment. Here, that's the graph I have shown you on the PPT, and you can see here the various types of graph from your optimized data you can take up, right? Like this. Got it? And since you have done already programming, so you can just anytime go with, you see here, more precise, 0, 1. Now let me learn. So it's taking little time because we have put up too much data. You can see on this screen, right? And you can see over here So the lines are created 100 lines per unit right now, right? And then various types of graphs we can have. Okay, so this is just one way I wanted to communicate you whenever we have the data and how beautifully we can plot with the MATLAB. Let us move ahead. So you can see this is the grid. Now we can move to the fill 3, patch, surface to patch. So we can have like plotting of STL file or any other file where we can want a filled surface, right? So that kind of filled surface we can have. Now see, we can add various titles to this figure, right? You can see over here on the x-axis, y-axis, and z-axis, right? See these values, right? These figures, these x-axis, y-axis values, grid, tick mark, the axis title, everything we can change, right? So either we can put this command title or else directly you can go and you can change. So if you are very good in programming, you can do it within the program itself, right? And you can have this kind of, right? The title values, the font size, right? The number of any other thing required. Okay. Now see, functions, we can control the axis. So minimum value of x-axis, maximum value of x-axis, y minimum, y maximum. Then if you want that there should not be any limit for x minimum, means this has to be depend on the whatever the data you have, right? So you can put minus in it, right? So this will be the maximum limit for x-axis and the minimum limit will be derived whatever the value you are found. Got it? So this way we can have the access control. This way we can have the menu control. Okay. Now coming to the MATLAB windows. Right? You can see over here on this screen we have the various ribbons, buttons for MATLAB. Okay. Now look at this. We have the different windows like command window. What it will do? It will give us all the variables and run the program. Then the workspace window that will provide the information about all the variables we have used and their current value. Then the command history that will also show you all the command you have entered to run the MATLAB. And by the arrow key, any time you can move upward and see any previous command, and just by pressing enter, you can execute that command, right? Then you come to the editor debugger. This is the main window where we write our program, we check our program, right? And we save our program in this .m file, right? This is the editor. Okay, then we have the current folder window, then the figure window. Normally it opens separately. I've just shown you the graph in the figure window, right? And the help window. The MATLAB help is very, very powerful. Anything if you want, we can type on the command prompt and then we can have the help about that program. So see in this case, now you can see the command window, right? That the title itself mentioned the command window, right? This is, right? Then you have the workspace window. So here you can see again, the title itself on this window is the workspace window. Okay. Then you see here the command history window, right? So these layouts we can change anytime. There is no point, we can make as per our convenience. So normally by default we use like this. This is the editor window. Then we have this current folder, right? You can see this current folder, right? Then the figure window, right? Then you have this figure window. Normally it is separately, but you can dock it within the layout. Suppose in some situation you want to have a print screen, right? And if you want both the windows to be printed, so you can do that. Then this is the help window, right? Now see in this command we can change. You can see here this is the layout, right? So from the home button you can come to the layout screen, right? And from this layout you can select whatever you want. Suppose you want to open this workspace window, it will come and become the part of the layout. And suppose we want to rearrange window position, so we can click on window title bar. So we can rearrange. I will show you once I'm going back to the MATLAB screen how to rearrange. Okay, we can just click a double click on this title of the window and then we can drag and drop somewhere else. So you drag it and the shape will keep on changing. Right? And suppose we want to go back to have a default layout, we can anytime go back to layout and then click on the default. So we can have the default layout, right? And then we can find out the various layouts like this, right? This you can see the dock and undock, right? On this screen, you can see from this small button, you can open this dock, undock, editor, right? So you can just double click on the title and you can undock. So this figure window will come out, right? Then let me go back once again to the MATLAB screen. Then I will discuss with one small optimization problem of nesting. Look at this. These are the various windows. You can see this the home, right? And this on the editor, right? And you see here, I can click it and drag it. So you see its size has changed, right? And you can see here this current folder become smaller. Now I have just double click it, so it has become full, right? Then I can undock it, so it will come out. See, it is now become a separate window, right? So we can close it, right? Or we can go to this small icon and then say again dock. So dock, it is went to its original position, right? So this we can do from here like undock. So it is moving to its original position by dock, right? And anytime suppose we wanted to go back, we can go to the layout and we can say default. So it's like default, right? So this is all about the layout. Now point is this, what we can do, we can have a new file. We can have this new file, right? Anytime we can open the script. So you see here now this is new untitled file, right? And this is just simple like a calculator. Say suppose for example I have the a equal to 5. So you see on the command prompt this says a equal to 5. Okay, then suppose I say b equal to 6. Okay, then now I say c equal to a plus b. Anyone, what would be the answer? Anyone? Okay, Natarajan. Okay, suppose I type a, sorry, a plus b. What would be the answer? Anyone? I hope by mistake answer has already come on the screen. You see here, undefined variable, because the MATLAB is case sensitive. For MATLAB, small a is different, capital A is different. Right? So anything if you define it, right, that will be case sensitive. Right? Now this is the command prompt. So these things are maybe forgotten. I can press arrow key and you can see by arrow key all the commands are there. And any command I can re-execute, right? But suppose this is the editor. So here I can type a equal to say 7, b equal to 8, right? Then C equal to, I can formulate something, A plus B to 3, right? And then we can run. So what it will do, it will overwrite the ABC. But now this is in the same program. Anytime you can open this file and anytime you can edit this file, right? Let me put run. So for run, I need to go to the editor and then run. So it is asking me to again save the file. Let me save the file. And it is untitled to the C equal to 39, right? This is the advantage. Now command prompt I am not going, but here if I can change anything and I can rerun the program, so the value of C is there, right? So this is how we can generate, okay? And suppose you know good error in line 3. Right now it's okay in this ABC line number. Oh, sorry. So why this is not captured this error? Anyone can tell? This is good, good, very nice, Rakesh ji, very nice. This is the error in line number 3, right? But why this system is not capturing this error? Anyone? Please write or unmute yourself. This is the error, but it is not been checked. Okay, let me run this program again before running this. Okay, now suppose I run this program, it will tell the error. Did you notice it? Previously it is not giving the error, but now it is showing that line 3 there is an error. Why? Because B was already there, right? B was already defined, that was available in the workspace. You can see here in the workspace window. Now right now it's only A, right? Because now B is not defined. But suppose now I will correct it. Sorry, B equal to A. Now we run the program. So you can see in the workspace now we have the A, B, and the C, right? And because the previous B was there, so that's why it was not catching the error. So these things will come only by the experience when we execute and do something in MATLAB, right? So let me coming back to the nesting problem. This is the screen I have shown you. See, in this case, what about the nesting problem? We need to optimize. What kind of optimization we need in the nesting problem? I hope many of you know the nesting to be done for cloth industry, the shoe industry, and the seat metal industry, or anywhere other where you want to maximize the utilization of the material, right? So to maximize the utilization of the material, what we can do? Here, this is the nesting. This pen stand is going to be made with this, right? So to make this pen stand, we want this kind of flat sheet, right? To be cut by the punching machine, right? So we will have a big size of the metal sheet and then we will arrange this kind of arrangement, right? Right? We will arrange this kind of arrangement to have the maximum sheet. Now you can see this small portion is unutilized in this case, right? Suppose I arrange another sheet like this, right? So you see this portion is again unutilized. That will lead to the poor efficiency or poor rate of material utilization, right? So what we can do, we can optimize these things, okay? So we need to write our own code to better placement of the piece of the material, and we can call it in a mathematical term now the polygon, okay? So for polygon, you can see here, see another example. This is the photo frame, right? Let me show you the original sheet. This is the original sheet you need to cut, right? Okay, so when you cut this sheet, this type of cutting is required from the punching machine. Okay, so you can optimize it and you can set various component of this photo frame on the sheet metal to put some algorithm so that you can have the best utilization of the material, right? See another example on the bottom side, you can see the original sheet, and after bending, you can see the external component of the photo frame, right? Now see a small example for a for little time. I am just showing you that you can see over here. These are the various objects I have taken. What computer required to have this product to be in? These are the XYZ coordinates need to be provided to your program. Say for example, is small component. These are the coordinate of it. Or you can take this example, right? So what the algorithm you can talk about? Okay, how to do this nesting operation? Suppose for example, this case we take, right? In this case, what you can do, you can next component can be arranged in this way, right? No need of mirroring or doing anything extra, right? Just you can arrange the components like this, components like this, right? Suppose this L you are taken, right? So what you can do here, the additional, you can arrange this L in the reverse order to optimize it. Do you agree with this, the L shape? Anyone can type. And do you know that what kind of CAD operation we have applied here in this case? The L shape. Anyone please type. Did you notice we have mirrored the object about the X plane? And we have also mirrored it about the Y. Or if you want to consider it 2D, you can consider. So mirroring about the X-axis and the mirroring about Y-axis. Did you notice? We have first mirrored it like this. Okay, then we have mirrored it like this, right? So what will happen? You just mirrored this first step, and then you have this object you have mirrored like this. So you got this object, right? And this object you are placing in this position, right? So you require lots of mathematical operations to be done. What do you call the optimization toolbox or different toolbox you find in the MATLAB? What are these toolboxes, right? Somebody like us have created a program, converted into an app, and then supplying it with the MATLAB. This we ourselves can also do. We can develop our own application. We can develop our own app, and then we can attach or we can install on any number of computer systems along with the MATLAB. Okay, I will show you one such. If I forget, you please remind. After explaining this nesting problem, I will show you that how to do that app also. So this is one. Let me come. Now what we have done in this program, you see here. Can you see here? On this we have taken some process parameter. The width of the strip 40. That input we are typing in the Excel file. And the MATLAB code is going to the Excel file collecting this information, right? Then it's asking for the first rotation. Yeah, can we modify the pro? No. That the people will not allow you. That's the thing. That's the catch. We need to develop our own program, right? That's why I am showing you this program. I will show you this program. That is our customized program, right? So some codes which are available in various forums of MathWorks as a open source software, those things we can collect and we can modify as per our requirement. But I don't think if they are selling out any commercial toolbox, they will allow us to change it. And that's why in today's talk, I have not chosen to explain you how to do the use of optimization toolbox, rather how to solve the optimization problem by using own code writing. Okay. So see here, this is the first rotation you have taken. Then the second increment, the precision in x direction means every time how much movement you want to give the second part. And then you are again checking if there is any intersection between two parts, then you stop movement, right? Then you see the results, the percentage of area utilization, you are receiving that 59.2857 something percentage, right? Then the width of the strip 40 you have already given. Then the number of polygon placed, it shows the 4. Then the length of strip used and means vertical side 7. Then the pairwise clustering is required or not, right? So see here, let me go to the previous slide. In this case, suppose I say this is the case number 1 and this is the case number 2. So you see case number 1, you have not made any pair, right? These are independent. But in this case, you see, you got a pair, your first component and your second component. If you make their pair, you can have the better optimization, right? So this is the pairwise cluster, right? Now you can see over here that the mirror position, you are talking about the fourth. Fourth means what? Mirror about X and Y both, right? Quite possible in some cases you may require the mirroring or even not require the mirroring, okay? Then this is the increment, okay? Now let me run this program and you can generate a lot of data to critical observation that how it is happening. And you see here, the rotation is 0, mirror position is 1, the increment is dx and dy, and this is the area used by the polygon, right? So from this you get, from this data you can find out where the area utilization is less for after pairing, right? In the second table you can find out in which combination you are getting the highest percentage of area utilization, and then you can select that result. Then you can send this data back to your MS Excel file, okay? You can write Excel file, you can write the text file, or in whatever way you want you can put that data, okay? So look at this one result. I will run this program, and if you see over here, this red color is the figure, right? Then the first thing we have done, we have sent it to the origin. So we have created a bounding box. You can see here the blue color. This is the bounding box starting from 0. So this is the bounding box you got, right? You have set the origin of this bounding box to 0, 0, right? Now look at this. This is the pairwise clustering. See here, right? Can you see we have done the mirroring on the y-axis as well and then the x-axis as well. So both side mirroring has been done to get this. Otherwise you see here the size is the 7 by 10, right? Now the total size is something 15, 16, 17. So otherwise if you put them independently, what will happen? 7 by 10, 7 by 10. So you would have used the area 7 by 20. But now you are using 7 by 16. So sorry, 7 by 17. So you are saving that 3 by 7 material, right? This you can see over here, right? And then the next step, you will arrange all the polygons. So you see here you got the 1, 2, 3, and then 4, right? But as per since you have given the strip width is 40, right? This 40. So that's why this much area is not used, this area. Okay. So that will lead to the percentage of area utilization. That's why you are getting the 59% of area utilization, right? Let me come back and show you this program on the MATLAB screen. Then we will, I will tell you how you, if you want to try, how you can get the offline trial version or online MATLAB for 1 month. Okay. So let me go back to the MATLAB. Let me find out this nesting file, right? So you can see over here, this is the file, right? Here we have taken the data from nesting file, okay? This -1 will open the Excel file and ask me to choose the data, okay? Right? Then this is XLS read nesting input from B5 input sheet, and the nesting is the file number. So this RP1, these values are coming from those Excel file. Okay. Then you see over here, then the polygon, we have to plot the polygon, check the size of the polygon, right? And the additional condition, if I choose the polygon, and then we need to check this is valid polygon or not, something like. Then we have the various things to do in this program. Not at the moment, I cannot explain, but you see here, this is the big program. No toolbox like this, and this is where we are writing the data back. XLS write nesting, and you see here whatever the data we are sending now, which cell, B70, B72 or 74 or whatever the sheet, right? So this is how we done the strip packing, and then finally we send all the information to Excel file, and then this is for the plotting. Whatever the data we have collected, we are going to plot, and also various functions also we have used, right? So you can see over here, this is the file. See, around 1000 lines, and the number of loops you can see end. This means there are 5 for loops are there before, right? And inside many other loops also. Okay, let me run this program. You see here on my toolbar, the Excel file is already open, right? I don't know whether I have closed it or not. Otherwise, so let me go to the data in, and suppose first we want to check for this, okay? LChain, since we have talked. So I've selected this data. I'm going back to the MATLAB and saying okay. So this file I'll already closed now, okay? Excel file is closed and the data has been taken by the MATLAB. Since I have kept many things open to be written on the command prompt, that's why it is taking some more little time. And you can see on the command prompt the percentage of area utilization, right? Let me show you the first figure. Can you see in this first figure? The red color figure and the blue color figure, which has been again changed to the origin, right? So let me show you first the first figure, right? This is the red color figure taken to the blue origin. Now look at the second figure. Sorry. Look at the second figure. Can you see here? This pairing has been done, right? The blue color component and the red color component, now they are mirrored and they are joined, right? So that's why you can see the length of the strip used now 3.6 something. You can see over here, right? This is the part 3.6. Okay, so that is what we have done, the mirroring, and both side mirroring, and we have done the pairwise mirroring. Now see how many components it has fit. Since you see we have given the width size, the strip width is 40. So up to 40 it has keep on shifting, right? So see what has happened. Let me maximize it. See what has happened. This is the result. You can see how the strips are width. We have taken the uniform polygon in this case, right? That is what. Okay, and if we take the multiple polygons, you can see this type of situation you may have in the class industry like this. I think I have forgot to see in this on my screen, right? So the different class components are there and they need to be fixed on this. Right? So this is the objective of this program. Okay, now let me go back. See, let us run another program for MATLAB. Okay, this we have taken. Now let us run for, again, it will ask me to open the Excel file. I have opened, I'm going into the data in, and let us select this component. Okay, where we have found no pairwise cluster. Okay, so let me go back. Okay, let the program run. And you can see this all data will be updated in this file nesting already in the current folder on the left side of the screen. See, because of this is the single figure, so you have the 89% of area utilization. Let it arrange, then we will talk. Here on the first screen, you can see is the red color, then the blue color sent to the origin, and you can see here the second figure. Let me close this first figure. Let us see the second figure. Right? You can see here how it has been arranged. Got it? And then now we will see in the third figure the number of polygons it has arranged. You can see here this is the coordinate. So you can see this number of polygons it has arranged. Right? It has taken the allowance in between, and you see the thing. So we can count the number, because since you have given the 40, or just you can anytime go back, and then all the information is already written in the Excel file. So let me go into this nesting file, open outside MATLAB. Can you see here the result? The percentage of area utilization 89%. Okay, and the number of polygon placed are 33, right? And the width you have given here the 37, so it has taken the data 37. And on the bottom side you can see here is taking mirroring. Where is the mirror position? You see here mirror position 1. Mirror position 1 means no mirror, right? Let me close this file and run it again. So you remember we have seen in the nesting file we have given the width strip 37. Let me run once again. The last time we are running the same file. If you have any question related how to do that, please ask. Data in. Let me take this time this file. Okay. Sorry. This is the file. Okay. So we have to. Right now we will go back to the. Just wait for the figure to come. Right, you can see here the first figure. Where is the first figure? Right, that's the figure. So this red color figure is shifted to the origin in the first case. Second case, you have done the pairwise clustering. Right, let us see the second figure. You can see over here. Right, see both the figures are mirrored, put together to make a pairwise clustering, right? Then you see here the third. Remember this time we have taken only 37, 35 and the 36. 37, right? So that's why width strip is 37. And you see here the 4 polygons are pegged. Now if we go back to the MATLAB, and you can see we can open this nesting file outside MATLAB. What has happened here? You can see the result. What we have obtained is now mentioned here. You see the number of polygon placed 4, the percentage area utilization 64, and the mirror position is now 4, right? So 4 means both side mirroring we have done, x-axis and y-axis, and the data input we have taken 37, right? So that's how we can develop our own program and how we can do the optimization by our own without going into the any toolbox, or you can have your own toolbox as per your own requirement, right? and that toolbox you can inbuilt in the MATLAB. You can see here, let me go to the app. You see on my screen app, this draw polygon. This is my own app. I have clicked on it, so I need not to share this code to anyone, right? Suppose you want to modify this app, you can't do it. This is my app, right? And what I can do here in this toolbox, I can enter say 6 for the inscribe circle. The number of side is 5. The line type is say dotted. The color is green. And let me plot the polygon. So you see it has drawn the polygon for me. And you see on the right side, the data. You see here the number of sides we have taken 5, the radius 6. That was the area and that is the perimeter. Okay. Now suppose I change the number of sides 7 and again draw polygon. You see here. So on the main canvas, you can see the polygon had changed, but the data has come. And you, most importantly, you see the recent data is coming on the up. Normally what you do in any table, your data will be entered at the last row. But you see here, this is shifted. Okay. Now suppose we want the previous figure should be maintained, retained. So I clicked on the retain figure, right? This is what the checkbox. Let me put the color black, change the line type to solid. Number of side, let me put 5. And the radius also let me put to say 8. Okay. Then I will say the drop on here. The new black polygon along with the previous. Anytime suppose I want to clear this figure, I can put the clear canvas and draw the polygon again. See, but the data is remaining in there. Anytime I can also clear the data. What it will do? It will erase the variable. So clear data, right? But any time we can again plot the data. So it is starting collecting the data, right? Anytime you can rotate this. You see here, we have created the slider bars, right? You see, I have created here some more buttons. So I can just go back to 2D. I can just go back to isometric view by 3D. More importantly, you can see I can go back to 2D. This is the toggle button. You can see toggle button. What it will do? It will switch on off. So grid on, grid off, right? In a dedicated MATLAB course, we discuss about all these things, how to develop this kind of graphical user interface. Okay, so this is the grid on, grid off kind of thing, right? So this is I just wanted to explain you how you can, just like a commercial thing, you can develop your own app, own program, own toolbox, and even you can install with MATLAB. And suppose I want to share with you, I can share this app. So you will not be able to modify, but you can install this app on your MATLAB as well. Okay. So if we have any questions, I'm open. Or else let me run another program to show you the optimization of toolpath in CNC machining. Then we can close the session. I hope everybody is now hungry and waiting for the dinner. You can see the another graphical user interface. I can select the various point 1, 2, 3, 4, 5, and say 6 points. So those who know the Bezier curve, they know how complex this calculation is. So I have plotted the Bezier curve. I have set the datum. So this has these to the 0, 0. Then the 3 CNC cycle turning, facing, and pattern repeating. So I'm not changing any value, but I'm just giving the CNC. So you see the program developed automatically calculating the intersection points, inserting additional points to it, and then making the toolpath to it. Right, so this is the toolpath optimization we can have. We can change various process parameters, we can have the toolpath, and then we can write this coordinates in the form of G&M code. So you can directly supply to the CNC machine. Let me show. You can see the view part as well. See, this is the part. That is the path you have created, and this is the part after the machining. You can see. You can rotate. You can explain to your student, and not only this. Remember, all CNC machines, they offer you the circular interpolation, not the Bezier interpolation, right? And then you can go to the right GM. So you can write this program. Okay. Suppose I say write today PKJ 8. So this entire program will be written as a text file in this current folder, right? Let's see in this current folder where the PKJ line, PKJ 8, right? Can you see the PKJ 8 text? Let me open outside the MATLAB. Here, the entire coordinates calculated by the MATLAB program appended with the desired G code for CNC machining, and these intersection calculation points of X and Z all are converted into, you see here, the 136 line MATLAB program. This we can directly take up to the CNC machining, right? So that's the idea for everything we are talking about, right? So I think now we can sharing screen, stop sharing. So if we have any questions, we can take up, and I think I've taken enough time from your dinner time, so we can close the session. Yeah, what you said, does their nesting export the data from workspace? Yes, you can do. That is our own. That's why I shown you that another program on CNC machining. Whatever the thing you want, you can export it to the Excel file, right? Can we modify? Yeah, this is the previous. Will you be sharing the material to us? Yes, I will share, but not certainly the code, the MATLAB code. I want you all should learn that MATLAB code, and if you don't have the license for MATLAB, you must learn for Scilab, right? That's the purpose of Dr. Nanda of organizing this course repeatedly, that people should not necessarily forced to use the MATLAB, but they can use the Scilab. And what I am asking about, at least you can avoid having the toolboxes. Let us develop our own toolboxes. Yeah, Dr. Nanda, over to you. So
Yes, I am very much thankful, sir. We have over here one room full with participants.
Thank you so much.
From MNIT. The lecture is online and the participants are offline.
Okay, okay. Oh, that's great. That's great. That's great. I'm missing those days when we conduct this program in offline mode. I remember people will not leave to their home. In 5 days, 6 days, they just become expert in MATLAB, Scilab, do a lot of exercises on their own system. It's okay, fine. I would request only thing, I will share you the brochure of this MATLAB. I don't know who is coordinating at the moment from MNIT Jaipur. You circulate it so the participants can register
sir,
wherever they want.
Yes, I will do it. I will do it, sir. So thank you. So participants, today our sessions will start sharply at 4 o'clock. So hope to see you all tomorrow. So thank you, everyone. This is the end of the first day session.
Thank you, Dr. Nanda.